Oh,
Just get that button again because I tried to do it to the cloud, but I didn't want to do that. Okay, yeah, we'll let it go. Oh, hey there, Chip.
Hey.
Just getting things finally configured. Okay. And Ruff, everybody, welcome back to the P2 Live Forum. It's been for me about almost 5 months since I've seen many of you. So happy to see this again. And if anybody wants to stop and open up their mic and introduce themselves, you're welcome to do that, or just use the chat if you prefer. I see some new names. We have huge sign up today, which is great. It was about a year ago that we did a holiday presentation with Johnny Mac around some LEDs and rotary encoder and an LCD display. And that was a lot of fun because it gave us something to do when most of us were not working. So this time we got John back with another cool toy. It's the NEXTION touch screen display. And I don't know where he's taking us yet, but we've got 3 meetings with this today, the 15th and the 22nd at 1 o'clock. And that's just the beginning of what's coming. So before I turn this to John, a little bit of information for you. Some of the hardware we're using today is the Propeller 2 Developer Starter Bundle. A whole bunch of ways to go about this, as you know. This price actually was last week's sale price, but if you don't own any P2 hardware yet, this is a great way to get it. So I'll just drop this link into the chat. You can go in there. So we'll be using that, probably not today, but next week, so you still got time. And then we're going to use the LEDs from this kit, okay, which is the P2 Live Forum Holiday Spin 2 kit, and that's on the Parallax site. We still have 66 in stock, so you can grab that. There's also the display itself. John will get that. So briefly, if you're having trouble getting chips, we are not now. So P2 first, we have, I think, 5,000 or 6,000 in stock. I have at least 20,000 more coming in the coming months. So here you go. As we talk about the global semiconductor shortage, here's your Made in America solution in stock and ready to go. So be like others and start designing this in. We anticipate no shortage, and the supply chain is pretty efficient for us. P1, we're still out of stock, but we've been filling back orders. The way that's been working is we're perpetually in back order. We just fill the next order that we have. And by early January, we will be upright by the quantity of 10 to 20,000 units. So if you're used to buying these off of our site, you'll be able to do that again. But until then, place a PO if you have long-term needs, or just if you're looking for development tools. Of course, we always have the P2 Edge. Let's talk about events for a moment. We're getting really good at this event planning. So we stopped and paused in November and December and put together a massive amount of events for you through this winter. We have, I think, 15, 16 days of possibilities here, depending on who you are and what you're interested in. So briefly, what are they? Where are they? They're on the events page. So I'll copy that link over. And this is continually getting updated, refreshed, and changed. Some of them that are coming. So if you're a teacher and you're here, that's great. You get to learn about the P2, but also this is an event for you. Next week, we're doing an overview on our educational tools for the microbit. And he's going to offer that. And he's also going to talk about a class we have coming up in March and April. It's a 3-day class for teachers. It's free. We send you hundreds of dollars of hardware for simply registering. After the Johnny Mac presentation of 3 events in January, we're talking about the state of our documentation. So if you remember, I'm sure we all do, in June, we kind of paused and said, we got to get this done. And Jeff has worked with Michael, Chip, Stephanie, and several others to bring the PASM 2 guide up to speed. So he'll be sharing that and then talking about the Spin 2 guide. So we've got some pretty solid efforts to share here, January. And then also January 19th, we hope to have some a good presentation on the P2 Universal Motor Driver add-on. I think that's an old picture of it, but these were being built on the pick and place when I was there on Friday. Actually, this is the selective solder machine. A little bit of a low res video, but this is 4 boards up. Everybody always likes these pictures. And what's really fun is if you're there, you can hear this solder searing. It sounds like a flank steak on the grill when it hits the circuit board. Almost makes you hungry. Anyway, we're working on that, and hopefully we'll have some results to share soon, and definitely by January 19th. And then on the 26th, Francesco Sant'Andrea from Italy is sharing his industrial controller with all the add-ons, and he's been ready to share this since November, but we've been delaying him so he can get more and more resources ready for it. And I think for this event, Chip and I will help him along because English is second language, and he's so enthusiastic but doesn't want to speak too much, so we'll be there to present what he's got. So I actually have one of these, really nice package. Let me see if it's behind me. I'll go get it and show it later. And then February 2nd, Eric comes back. What a nice friendly guy he looks like in this picture. He is too, isn't he? And while we're on the subject of flex spin, flex prop, etc., this should really be called flex prop because he'll probably talk about all the languages. I've had the request to add subforums for different languages in the P2 forum, and I just want to check with y'all on that before we do it. Is this something you would like? Do a little bit of muting there. Okay, someone's got to mute themselves. We'll pause while we figure that out. Okay, looks like something on YouTube took off. Sorry about that. So, would you like subforums under the P2 forum for different languages? And the reason I'm asking is because I've had a lot of interest in BASIC lately for machine control type applications. Any thoughts on that?
It sounds like it might be a good idea, so we can separate out the discussion. I don't know. What does anybody else think?
Kind of leaves the hardware questions in the upper forum and then lets people dial into where they need to go. I'm interested in it because I think the BASIC has a following from Parallax's basic stamp days, and they're always looking for somewhere to go, and they've been pretty happy with Blockly Prop, but maybe they would like this. So barring no reason not to do that, I'm just going to make that happen. Okay. And then in February again, we have another presentation. This time it's about Arduino. It's for teachers. And then February 16th, Chip and Jeff will show a prop tool with debugging and floating point. And then we have more content for teachers. This is a basic electronics workshop. And then, hey, Stephen, this is you.
Hey.
February 23rd. And if you notice, I have a void in between all of these days. So we could move things around. If you're responsible for sharing something and you want to adjust it, we could do that. So don't be afraid to ask. And then also, if anything new pops up, we could insert that at any time.
And just to comment on this, driver proof of concept is working. It's a quarter of the memory utilization that it was before. And it goes all the way from 3-bit to 8-bit color resolution, just dropping in frame rate. So it gets interestingly capable, and it's working. I just got to finalize the code.
Awesome. You've got a solid year into this one.
Yeah, we're getting there. It's getting fun.
More for teachers. That's a 3-day workshop with Python and the Cyberbot. And then another 3-day session for teachers, and then 3-day class for teachers who want to use Arduino. And then around March 9th and 16th, we have a 2-session event that's just part of the P2 forum. I'm asking Michael to share his best practices for PCB layout using the P2 Edge, and then we'll make sure all of our files are available to anybody that wants to integrate the connector into their project. And we'll also have on the second day of this presentation a special project board that we made from the actual presentation. And Gavin has been working. Professor Gardner is just really working hard on his book. He has another month to complete it. So he's coming back at the end of March for a presentation on mechatronics with the P2. So that'll be really cool. And then unfortunately for this one, we never really officially announced this. In fact, I think we just discussed the P2 Expo at Parallax for March, but we've officially canceled it given the unknown state of things. But here's some pictures of the way it used to be, which is really fun. We had at one point 2,000 people at our office for a day. And these are food trucks with burritos and stuff. And then this was really funny, the tour line in the lower left-hand corner, 2,000 people lined up for a tour of Parallax. Imagine that. And of course, here's Rick with his BS2PE Gatling gun shooting at our quadcopters and kids with robots. So we really want to get back to that, but at this point, yeah, we just can't commit to March. So no save the date. Okay, Johnny Mac, before we pass on to you, I'm going to copy a link into the chat here where I'm about to go make a deposit to our guest presenter, Johnny Mac. And I encourage you to do the same. This is always money well spent, and you could put that it is a gift. And I know John doesn't like this attention, me drawing to it, but John saves us so much time with everything he does. So let's keep encouraging that. And if you're going to use the content you see today, you could thank John personally. So with that being said, live from Hollywood, California, I pass you to Johnny Mac.
There I am. Okay. Hello, everybody. Yeah. Thank you, Ken. And hello, everybody, old and new. Hopefully the new people will not be terribly shy. I'm not a terribly formal person. You know, I'm a regular guy. I actually live on the other side of that hill. If I was sitting where it looks like in that picture, I would actually be in Hollywood. Burbank, where I live, is on the other side of that hill. And that's really where the magic happens. I live right around the corner from Disney Studio and Warner Brothers Studios and all those kind of things, and do a bit of work in the movie industry. So again, I'm addressing the new people now. Again, since we're not very formal, my name is John. People call me Johnny Mac. If you call me Johnny, I won't hear you. So please call me John or Johnny Mac. And speak up. We don't want anybody to feel left behind, especially since this is kind of the approach of throwing you into the pool to teach you to swim. So if you struggle, just say, hey, I need a bit of help, and we'll stop there. The great thing about Ken recording these sessions is that after, you know, you get a meal, you can go back and rewatch things. You can blame my actor's ego. I tend to go back and rewatch the sessions to make sure I didn't make any big glaring mistakes or do something silly that my acting teachers or friends would be embarrassed about. Can't help that. But at any rate, the stuff is available. Ask the questions and have fun. Today, we're going to be talking about the NEXTION HMI, which I have one here. This is a bigger one, not the one we're using. Today, we're going to use a slightly smaller version, but HMI stands for Human Machine Interface. You probably know that. And we tend to think of HMIs as touch panel interfaces. I think of them a little more broadly. I work for a laser tag company, and our taggers, our weapons, have buttons and an LCD on there. And I have a code module inside that product that I call HMI. So human machine interface, it's a way for a human to control a machine, usually with some visual stuff. This is a touch panel display, so it's going to be very visual. Hopefully, those of you that signed up downloaded the NEXTION Editor. You can follow along once I start sharing my screen, you can see everything, but you'll probably have a little bit more fun if you are also running it on your screen so you can try things. The goal of all of this is to take the hours and hours and hours that I spent watching other presenters talk about these products on YouTube, distilling the really useful stuff and applying it to the propeller. Now, you'll see if you go to YouTube, there's lots of videos about the NEXTION displays. They tend to be connected to the Arduino, which is fine for people using the Arduino, but we're using the propeller. Luckily, it's a serial device. Serial works on anything. So I'm going to present a strategy that makes sense to me and hopefully will to you, that you can use on the propeller too, which is what we're doing today, but it'll easily port to the propeller one and any other processor that you're using. Now, Ken mentioned Eric's compiler. I've seen in the forums, there's a lot of popularity with his basic in there. There is no reason why what I'm telling you today wouldn't adapt to that. It's very simple serial. And, I live and work in Hollywood. There's not a lot of brain surgeons in this city, certainly not me. I keep things very, very simple. So any questions or concerns before we start? Today, we're going to be focusing on the NEXTION display. We're going to talk a little bit about P2 stuff. I guess I should follow up on Ken's since I have 3 weeks. Next week, we're going to talk more about NEXTION, but a lot about the propeller and specifically how serial works, how I2C works, and how the smart LED protocols work. So you'll understand the internals of the protocols, and we'll write code to test those hardware things. And then on week 3, based on some input I get from you next week, we'll have a little lighting controller project that we can control with the display and light up the Christmas tree or the front yard or whatever you want to do. But I want it to be a little bit participatory. So as you're thinking through the week, say, hey, I'd like to see this feature if possible. Now, no promises, but somebody in the forums did ask for me to cover a feature of the NEXTION that I hadn't been using. So I looked it up and I've added that to the presentation today. So I will try to accommodate any requests that people have. Any questions before we start fully? Yes, sir.
Quick question, Johnny Mac. So hardware to have ready for next week and the week after, the WS2811, B12, those LEDs, a display, and a P2.
And the real-time clock module.
The RTC.
Yes.
Okay.
The clock module, the LEDs, your P2 setup, of course, the Johnny Mac being the preferred by the Mcphalen household. But any P, there you go. That is my signature. Any P2 platform that you can connect things through. The nice thing about the Johnny Mac is that we can connect a reasonable current 5-volt power supply to it, which will power the LEDs that Ken showed you.
Thank you.
And so that other things too, like I threw out today, hopefully, on your desk or in your parts bin, you have a 10K pot. So you can do one of the little demos today. If you don't have it, it's not a problem because I'll show you on my screen and you'll see how it works. Also, because Ken, you remember this, Ken had asked me to write a driver for the DHT22 temperature and humidity sensor. I'm going to demo that today with the NEXTION. And just for giggles, and this is in the source code, I have I don't know if this will show, I'm going to lift my board here. I've got a ridiculously cheap little, that's this board right here. It's supposed to be a pulse rate sensor. Doesn't work very well, but I'm going to show you that in conjunction with the display too. So I have a lot of stuff today, a lot of it having nothing to do with Christmas lighting or those kind of things, because today is all about here's a whole bunch of different ways to deal with the NEXTION so that when you're creating your own projects, you understand all the bits and pieces and can really put them together effectively. It is a thing, and their support people get very hardcore about this. You really need to think about it going in because it's a bit of work. And so there's a process to going through it. If you work through that process, your life will be okay, fine. I have spent a lot of hours, I didn't do that and, going and redoing things. So again, the goal of all of this is to share what I'm doing. Hopefully it is appealing to you, or you can take it and say, you know, that guy's a yutz here. This is a better way. I would love for you to say, hey, Johnny Mac, here's a better way to do that. Because you know, I'm here to learn just like everybody else. Okay. All right. Can I share my screen, Ken, so I can go between apps?
Yep, have right at it.
All right. I want to share my screen, not an app, right?
Yep, we see your browser now.
Okay, so let's go right into the my PowerPoint. So are you seeing my PowerPoint?
Yep.
Okie dokie. So here's me, Johnny Mac, and we're talking about the NEXTION HMI. I already discussed these things. HMI stands for Human Machine Interface. We're going to be dealing with the NX4832 T035. You can see what those numbers mean. 48 is 480 pixels. 32 is 320 vertical pixels, and 3.5, it means from here to here is 3.5 inches. So that's, so when you're looking at NEXTION part numbers, that's how you decode their resolution. It's these two numbers, and the size is that. This uses a resistive touch panel. It will display 16-bit color in 565 format. So what that means, if you're used to 24-bit color where you have 8 bits each for red, green, and blue, this will use the upper 5 bits of red, the upper 6 bits of green, and the upper 5 bits of blue. That actually comes into play in a part of the project that I'm working on, where I wanted to create a screen with RGB sliders on it to control live the color of, you know, the string, so we could experiment with color settings. But I want a little color patch on the screen as well. Well, that uses 565 color, so I had to go through and work that out so that the color patch matches relatively closely to what the lights are doing. So we'll see that maybe next week, definitely the week after. These displays have 16 megabytes of flash. That allows you to store all your resources for the screens and widgets and all of your other things, and 3,500 bytes of RAM. I have not run into an issue with RAM in any of the simple projects I'm doing. There was a project that I have an image of. I don't think I included in the downloads, but I can if people want it, that when it compiled, it was 20 megs, and this is odd because the editor, even though I said, hey, I'm using this display, it compiled it, said it's 20 megs. And I thought, well, let's give it a try. I put it on an SD card, stuck it into the display, and the display said, yeah, sorry, that's too big. So you do have to be careful of that. And the different versions, or the different families, if you will, that's probably the best way to say it, of the NEXTION displays have different memory and processor and speed requirements. The great thing about this, you can see here in this graphic, there's just 4 wires, and black is ground and red is 5 volts. Then the yellow and blue wire is just TTL serial. Now, interestingly, even though it's a 5-volt device, the serial is 3.3 volts for the basic and the enhanced, which is the black displays and any in that range. Be careful if you're using the intelligent display, this uses 5-volt serial. Now the P2 is really resilient, but you don't want to be banging 5-volt serial into the 3.3-volt device. So there's a connection diagram that I added to the files a while ago that shows in the blue wire is the transmit out of the NEXTION. If you just put a 4.7K resistor in that, between that and the P2, you're fine. Okay. Now the default baud rate is 9600. I've tested it up to this rate, you know, 23400, and with no problems at all. And in fact, with downloading serially, I've gone up to almost 1 megabaud because that was supported by the driver I had. So again, the connection diagrams will show that. Any questions? Okay, please jump right in. Don't be shy.
Hey, John, I have something to say.
Yep.
We have PASM instructions which can manipulate RGB 24 data. And we also have ones called RGB squeeze and expand that will take that 888 data and squeeze it down to 565 for display, which is what this thing uses. And then we can also go the other way, 565 back to 888. so that you
Okay,
can use the pixel instructions.
well, that'll be good for when we want to change a color patch or a color on the display. On that particular project that I'm doing, I have 3 sliders on the display that are updating. They're creating a 24-bit color, but they're also creating a 16-bit color for the color patch on the display, and then they're transmitting serially the 24-bit color. But it'll be, I was thinking, I knew that those things existed. It'll be good to show that in practice so we can change colors, because you can, I've not used it. I'm using standard widgets, but there are drawing routines on this display too, where you can, set an area and fill it to a specific color. I'm not doing that yet, but being able to take a 24-bit color and knock it quickly down to a 16-bit color would be very useful for that. Okay, this is what the editor looks like, and this is the starter project we're going to do today, using not all, but quite a few of the basic widgets. It is a Windows program, but I know my friend Rick runs a Mac and he had it running on an emulator. So I think it works fine for people that are in Mac. It did at Rick's house. And we'll go through all of these later. This is the editor. It's pretty nice. It works really well. There's a couple little gotchas that are annoying that I've said, hey, why does this do that? Today I asked, for example, about something I'll show you in just a minute, and they said, oh yeah, we can't do that. So I made an adjustment to the color scheme on one of my projects to adjust for that. But as we go through, it's very much, if you've used Visual Basic or any of the Microsoft compiler products, it's kind of like that. And since I brought up Visual Basic and other things, we are going to code this thing, but it's not going to be a standard program or a program similar to what we put into the propeller, where we have a big long listing. Everything within the NEXTION display is event driven. So all of the widgets and the system have events attached to it. So we're going to just put little chunks of code where appropriate into events. So for example, an event is when you press a button on the screen. There's a press event and there's a release event, and you can stick little chunks of code into those events. So a lot of the coding is just very small segments. It is a script. It's not a programming language per se. I guess technically it is, but I'm calling it more of a scripting language that looks a lot like C, but it's not C. There are things that I tried to do that are valid C instructions that didn't work in the NEXTION. So that's one of the little hurdles, and it probably will be, especially for very hardcore C programmers, because you think, geez, why can't I do this? And I'd ask for help in their forums. There was things that looked very obvious and that the compiler didn't complain about, but I got bad results. So I'll show you what I've learned along the way. You certainly have all the projects that I uploaded have code in them, so you can see how to do various things that will probably be useful. So as we go through, this section is where you build the project. So you're gonna click on a widget over here. It's gonna show up, and then you can drag it and position it and do what you need. This is shown on my screen now at 100%, but there's a slider up here that you can use in the editing mode. You can expand the screen, so that helps you with fine positioning. Remember, as human beings, we take an enormous amount of information through our eyes. So spend time to make your project look nice, even if you're using just the standard widgets. You notice I have a lot of, everything's lined up neatly. I have even spacing. Those kind of things our eye is naturally drawn to. So be wary of that. You can also press and hold the control button and use the scroll wheel on your mouse to zoom in and out. I have to do that a lot. There's a couple of widgets that they have a transparency feature that will show an underlying image. And when you move the thing, it doesn't update correctly all the time. So if you zoom in and zoom out, it'll refresh that. So getting used to the control zoom wheel will help when you're putting things together. Why didn't I? So here is the widgets library. This is a list that will not have everything available. That's going to depend on your device. Sorry. So this is where we'll be selecting widgets. We'll click on them. They'll show up on the display build area, and then we can move them and set them up. This area contains resources that we're going to include in the project. In the basic display, the resources that we can include are images. You'll see I have images of the greatest comedy trio of all time, the Three Stooges, and also fonts. You have to pre-build fonts before you can use them in the display. So we'll talk a little bit about that. So this shows the things that your resources that you're using. Again, because of memory, you'll want to make sure that you're only including resources that you're actually using in the project. Don't stack up a whole bunch of fonts because they do consume space, which means it gets downloaded and it's using space. So be aware of that. This window will give you compiler messages when there's a compile button right there, or if you go into debug, it runs the compiler first. So this will show you what's going on. If there are any errors, they will show up in red text here, and you can double click on them and it will take you to the line that's giving you the code error. And the code editing happens right in here. It's probably a little hard, especially through the Zoom thing, but there are 5 tabs on this particular screen. So those are the different events available for what we presently have selected. And so you have separate code in each. This is where we edit attributes of whatever we've got selected. So for example, this top box is a text box. So that'll give us our XY position, how wide it is, what font we're using. If we're, like in this case, I'm using a solid background color, all of those features. So all of the attributes of the widget or object, they call them, are edited here. And then finally, this is where we can select our pages. This particular project is a single page. And so you see one there, but on a multi-page project, like my friend John, he's got a whole bunch of pages there. They're kind of generically numbered, page 0, page 1, page 2. You can rename them though, if you'd like. Okay, so that's kind of a tour of the editor. Now, I think the best feature of the editor is the debug and simulation tool. So when you click debug here, it will compile your project and it will throw it into a simulator. And then it runs live. This is the serial input window, so you can talk to the display. This is the output from the display. So when I'm working on a project, I'm spending a lot of time here checking all the messages, seeing what's going on. And once I'm happy with all of that, then I can hook it up to my propeller and I know what to expect. The other great thing about this, is probably hard to see on my screen, but right there it says use MCU. If you click there, it will take commands from an external device. So I'll show you that in a couple of the projects that I uploaded, there is a constant called simulator. And if you set that to yes, when it creates the serial object for the display, it connects it to the programming pins. So for example, I've got a little 10K pot on my Johnny Mac. So when I do that analog display, I'll be able to turn the pot and I can see it in the simulator as if I was running it on a live display. It's a really, really useful tool. It saves you a lot of time, because what I had been doing before I paid attention to that and put it to use was I would test in the display and then, in the simulator, and I think, okay, I think I've got it. And then I would compile it. I would output and stick the file onto a micro SD card, turn it off, pop it in, let it reprogram, turn it all back on and test it on my display. Now that's my very last step. I'm doing everything through the simulator, including my P2 stuff. If I don't need P2, if I don't need to use PST or the P2 debugger, that's the caveat. Because this is going through the programming port back up into the PC. So if I don't need PST or the P2 debugger windows, then I'm able to run everything right on the screen. I found that very, very helpful for testing and development. Okay, pretty quiet crowd so far. No questions? I'm gonna have to get Ken to round up questions.
There's so many people in the room. They're
Oh.
probably scared to draw attention to themselves.
Yeah, come on, have courage.
John, where was that button that you were just talking about that simulates the inputs or sends the inputs to the simulator?
Down here at the bottom of the simulator screen, Carol, you see where it says right there, use MCU input.
Yep. Well, it's really hard to read. It's really small.
Yeah, it's right down here. So when you're running the program, it'll be much easier to see. When you do that, and I'll show you, it will ask you for the serial port and the baud rate you're using, and then then you're sending serial and back and forth between the P2 in that case going through the programming port and the simulator, just as if you were sending it to the display.
That's
So
cool.
it's really a great feature. Yeah, about a week ago, I finally paid attention to that, and I thought, gee, many Christmas, I could have saved myself a lot of time had I been doing that earlier, of just constantly downloading, to the display, and not wanting to have. I tend to use the SD card method, so I don't have to disconnect it from the display or from the Johnny Mac. But you can program the device serially from within the NEXTION environment. For just experimenting, if you have just a USB to serial adapter, you can even, and I tried it, it works. If you hook up 5 volts to the display, you can use a prop plug. That works too, since it's a 3.3 volt interface, but you have to use 5 volts for the display. Somebody in the forums, I think Jeff Rourke, he was having some trouble, was giving him some weird things, and then he figured out he had connected 3.3 volts to the display instead of 5 volts to the display. The power supply into the display has to have 5 volts. Again, on the basic and up through the enhanced displays, they use a 3.3 volt interface, so you can connect directly to the propeller or directly to a prop plug. Sorry, I belabor this, but I just don't want anybody to hurt anything. If you're using the intelligent displays, put a 4.7K resistor in the transmit line between the NEXTION and the propeller. You can put it in there no matter what display you're using. It won't hurt anything, but it'll certainly protect the propeller when you're using the intelligent displays.
I use the
Quick one.
based on your diagram. So thanks for your diagram.
Oh, you're welcome.
John, a quick observation, if you don't mind.
Yes, please.
2 things. There are interesting warnings about underpowering the displays at the NEXTION site. So you probably want to at least take a look at those. Secondly, operationally, you could, if you wanted to enlarge the screen a little bit, you can go to presentation mode and we'd see your slides a little bit larger. Thanks.
And also, as an alternative, view options on the top of your Zoom display has a zoom ratio you can use to get in there too.
Are you talking on my display or the?
No, for the viewers.
Okay.
And John, question for you. There's no code posted yet, right?
No, I put everything up about an hour before we started.
Awesome. If somebody could grab that forum thread and put it in chat, because we had a few requests.
Yeah, it's
Thanks,
the one
John.
that I started. It's like getting started with the NEXTION. The top 2 threads have the P2 code that we'll use today, and then all of there's 2 zip files with NEXTION stuff that we're definitely going to use, and then there's some option stuff that I'm going to show you. You don't have to have those, but you may find this stuff in there useful later.
John, this
Yes.
is Jim Huber-Setzig. I have a question about the NX4832T035. Does
That's
it
what we're
have
using.
any
Go
does it have the one you're does it have any GPIO pins that we can use?
No. The intelligent display, the enhanced display, I believe that's where you get GPIO. The basic display, which is the one you just mentioned, and I'm looking at it, NX4832T035, TAC 011. That's a basic display. The intelligent displays that have a black PCB, they have I/O on them. In fact, there's a little port on the board, and the NEXTION people make a secondary board that plugs into that with a ribbon cable that has I/O.
Thank you.
Yes, sir. Okay, so this simulator we're going to spend a lot of time in. It is, as I was saying earlier, I think it's the best part of this project. They've done a nice job. Now, the one thing about the simulator is, as somebody was asking, and even I was trying, there's no zoom feature. The simulator runs 1:1. So we're using a 480 by 320 display. We're going to see it look like this. Okay. All right, so these are the various objects that we're going to talk about and that I've been using, some more than others. There are more in the list, but I think once you get a handle on how the objects work, and you can then look into the other ones and have at it. Text does what you think it does. It displays text. You can set the alignment within the field. You saw in that image, I had kind of a wide white field. You can set the maximum number of characters. The interesting thing about the text, in fact, the text, number, XFloat, and button, all of those require a font. So we'll talk about that, and I'll do a demo on how you add a font into your system. So what you end up doing is pre-compiling the font that you want to use. What I recommend, that, and I've done this in my NEXTION folder. So when you install the NEXTION software, it will create a NEXTION folder with demos and stuff in your documents folder. Underneath that, I put a fonts folder. So when I compile a font to use in a NEXTION display, I save it in there so it's available to any other project, and I have it in one place. So just a simple bit of management. Number will display a number, easy peasy. Again, same kind of things. You can decide how wide it is, its color, its alignment, etc. And so the text object has a .txt attribute. So that's where you'll set the string that is holding your text. Number object has a .val attribute for the value. So you'll point a value at that. And this is going to be a signed 32-bit value. So in the same range we use in the propeller. XFloat is the same as a number, but it has the ability to insert a decimal point where you want it. So it's not a floating point number, but it looks like one. And I demo that. I'll demo that today in one of the projects. A button is what you think it is. It's a push button, and it has various attributes. We're going to talk a lot about that because they're kind of boring and plain right out of the box, but there are mechanisms within the button object that you can take advantage of to make really attractive buttons and displays. Same thing. Progress bar does what you think it does. It's a progress bar. Goes 0 to 100. You can set the on color, the background color, the size, etc. Their picture, it's a picture. We'll talk a little bit about that. I didn't include it because it was a very big file, but I'm going to show you a dashboard display somebody did for a car simulator that uses pictures instead of the gauge display to make a much nicer tachometer display. Crop is actually quite a useful thing that I've been using where for example, I'll explain what I do with it and it'll make more sense. I have an example I'm going to show you that has a couple of LEDs on it that can either be off or on. So the way that I do that, instead of having individual picture elements, I have two layers in my project where I have an image of my display with everything off and another one with everything on. And so what I can do is I can put a crop field in that space and I can tell it which of those two images I want to display. So it becomes a really easy way of taking a portion of the display and changing it. Again, it will make better sense when you see it. Hotspot is like a button that's invisible, and it's quite useful for a lot of things. One of the interesting things about the NEXTION as well, since I told you a while ago, all of the code is attached to objects, to events that are connected to objects. So I being new, this was a month or so ago, I said to the NEXTION folks, how do I make a subroutine that I can use in a whole bunch of places on the same page? And they said, add a hotspot, put the code into one of the events, and then you can call it from there. So you'll find there's kind of a language to talking to the various objects in the NEXTION display. A hotspot has a click event. So it has a on and off. So you can do click on or click off, and you can put different bits of code in there. I use that feature in one of the demos I'm going to do today. So it's a different way of thinking. Hopefully when you've seen this, you'll say, okay, that's weird, but if that's how it works, that's how it works. And again, I've been collecting for the last couple of months other people's projects and analyzing them and kind of distilled them down to a system that's working for me and my friend John and Rick. And I'm doing a kind of a side project for the laser tag company using the display. It's neat. It's different, but it's neat. Gauge is a dial gauge. It's not great. I'll be candid with you. I don't really like the gauge. I've got a demo that I did for Rick in here to show you how to deal with the gauge, but in the basic display, the gauge is kind of janky looking. When you get up into the better displays, the gauges are nicer. Waveform is kind of an oscilloscope kind of display, or a EKG kind of display, where you have a grid and you can't write to specific X points. You add to 1 to 4 channels in there, and the data will either scroll left to right or right to left, depending on how you set it. So every time you add something, it just inserts a new column into the display. You can also clear the display and a couple of other features. I am going to demo that because somebody in the forums asked how to use the waveform. A slider does what you think it does. It's a push slider with a thumbnail, so you can set a value that's in the first project. Timer is a useful object in that it will fire at a given interval. 50 milliseconds is the shortest interval. And then on that fire event, you can run bits of code in the display. So for example, if you were creating a countdown thing, then you could every second, count down a variable and change the text field or whatever you wanted to do. In that, I was talking about that 3-slider display for the RGB stuff. One of the things that I was looking at is, instead of flooding the propeller with a bunch of messages that we probably don't care about anyway, on that screen, what I do is 20 times a second, I send the new color, if it's changed, down to the propeller. That way there's plenty of time for the propeller, 50 milliseconds in between, to get the thing and update the LEDs and do other management stuff. And from a human standpoint, at that rate, it still looks very smooth. A variable is actually an object in the NEXTION display. Now, this is a page variable. There are global variables that are just integers that we can use that will go across pages, but on a given page, you can have a variable and it can be either a number type or a string type. So we will see that, but you can't just say, let's say you have a variable called RPM, like if you're doing a tachometer display. If it's a number type, then to get to the value, you're going to say RPM.val. If it was a text string, if it was a text type variable, you would say name.txt, and then you would use text in there. The dual state button, the checkbox, and the radio are all kind of related. So a dual state button is a press and stay on, and press, push on, push off, I guess is what you'd call it, right? So you press it, it stays on. You push it again, it goes off. A checkbox is just like a checkbox in Windows or any other OS. The radio box is the same as a checkbox, it's just round. So the little thing about the radio box is that there's no automatic grouping. Like if you're developing a piece of code for Windows using, Delphi or VB or any of those kind of things, and you have a radio group, when you click one, the others will automatically go off. That's not the case with the NEXTGen radio. So it's a round checkbox is what it is. So in that first project, I show how to code it to make it work like a radio button. Okay, so there's quite a lot of, this is a big chunk of the list of objects that are available in the NEXTGen, but not all of them. Hopefully though, once you've seen these in practice and looked through the code and played with it and experimented with it and break it and fix it and do all those things we do as hackers, it'll make sense, especially then when you go on to use other objects. So any questions so far? Because I've been talking a lot.
Yes, sorry, John, could you repeat one more time what the crop was used for?
Yes, it will selectively show a portion of the screen. So it'll be much easier to see in practice, but let me say this. Let's say I have a screen image and then I have another screen image in my project, and then I have a little crop area right here. I can tell that crop image, I can tell that crop area which image to grab that underlying section from. Does that make sense? So it's like a masking control, if you will, and it says use this layer or use that layer. So again, in practice, you'll see it. It'll probably make better sense once you see it versus my explanation, but it allows you to crop a section of the image of your display. Now, this is predicated on you having a full image in your display, which I do in most of my projects. If you do that, then you can select what shows underneath the crop area. So as I was saying earlier, I have this project where I have an LED that's off and I have another copy of the screen that has that LED on. I put a crop over that. And when I set the crop value to 0, it shows the off version of the LED. When I set the crop version to 1, it shows the on. So it's a masking control. It's just selecting which layer is showing through that portion of the screen.
And each layer has to be a full screen?
Yes, for the crop image you do. There's other ways to do that. For example, I'll show that tachometer project, they just put pictures in certain spaces. So the advantage of the picture is you can move it around anywhere. So there's, different ways of doing the same thing. I tend to use the crop because I'm using textured backgrounds a lot.
Gotcha.
I want to make sure it's absolute control. So there are advantages to both. Again, that TAC project that I'll show you, for example, the oil light, he puts a picture and it's either white if it's okay. If the oil or the temperature gauge goes too high, he changes it to red. And so he's just changing the picture image there. So in that case, as the developer, you have to have 2 picture images that have the same size. And you'll see that like in the Three Stooges project, that thing we're going to do first, all 3 of those images are the same size. So there is a picture element, and we just select which of the compiled resources, because I've got all 3 pictures compiled into the project, are showing at any given time. So different ways to do the same thing.
Thanks.
Yes, sir. Anyone else? Okay. All right. So this is my suggestion for workflow. Sketch your project. Paper, I do a lot of that. I'm also a big fan of Inkscape, which I use for my projects. Inkscape is a vector tool, but it will output PNG files, even JPEGs if you want. I don't tend to use JPEGs, I use PNGs. And but the great thing about using a vector file is you can do everything nice and smooth. You can scale it as you need. I like Inkscape because I can use a snipping tool from Windows to grab an image, and I can drop it into Inkscape and I can trace over the top of it. So for me, it's a very, very effective tool because I use it for a lot of things. I use it for creating odd shaped PCBs, for my laser cutting stuff. I have a vinyl cutter that I make stickers for friends. So I use Inkscape a lot. It's freeware. It works pretty nicely. And I'll show you. I have it loaded up so I can show you how I use it. In fact, in the project files, the NEXTION project files that I uploaded, I included all of my original artwork in SVG format. So you can open that with Inkscape and grab elements if you like, change them or whatever you want to do. Excuse me. So then assuming you're doing the arty version of stuff, create your art. Again, I use Inkscape. Then create and custom organize your pages within the NEXTION Editor. Drop the code into your events. Test with the simulator. Now there's going to be a lot of iteration right in here. If you can, run your propeller code into the simulator and then drop the compiled TFT file into the display and hook it up to the propeller and away you go. So again, don't take this lightly, unless you're just playing. But if you're going to do a serious project, for example, my friend John, when he started on his project, he created a whole map of all the things he wanted to do, kind of laid them out and so that he could see where the flow was going to be. Then he created those individual screens and then he pulled them into the NEXTION Editor. Now, the editor allows you to reorganize things, but it's nice to have a plan going in. Okay, I think that's the end here. Oh, sorry, here's some demos. So here's some things that we won't go through all of these, but in code, but it's available to you, and I'm happy to do show you. So this is a very simple demo that I copied somebody from the internet. They were I don't have an iPhone, but apparently the iPhones have a screen that looks like this for doing a passcode. And the guy on the internet actually just did a screen cap from his iPhone and dropped it in. I recreated this in Inkscape. So in Inkscape, there is, you'll see, now this is, I copied from the simulator, but there are two versions of the screen. There's the off screen and the on screen. So the off screen has the buttons in this color and all of these circles. So this is telling you there's 7 digits in the code. And it has then the, how am I doing that? Can't remember how I did this part, but it's got the lock and unlock things. And then the on has all of these filled and all of the buttons highlighted. So when you press a button, it highlights and then it fills in a dot as it goes. And if you get the code right, you see unlock. If not, it just re-clears, and that's very simple. This is a text field. So if you do have this connected to a microcontroller like the propeller, you can very easily change this message. I have another variation that's a little more sophisticated that has the ability to lock out the keyboard. It's an escape room project that I'll talk about in a minute.
John, take a long swallow while I ask you this question. So on this thing here, since you have 7 digits that you're typing in, do you have to have 7 full-size screens where you color each circle one at a time? No.
This is where the crop comes in handy. So I have 7 crop widgets on top of this. So I have a screen that has all of these empty and one with all of them full. And then I have a crop widget over each of them. And so I can say, show the empty screen or show the full screen.
Oh, that's a good example. Thank you.
So yeah, and we'll run through it. You'll see it in the code. It'll make a lot of sense. But that's where, so for this, there are, in fact, on a lot of my projects, I have 2 screens, the off version and the on version. And then I use crops, or for example, if I'm using buttons. Now in this case, in this case too, there are buttons that I put over these things, but the buttons, instead of using their normal widget, I make them, it's called a crop image. So it will show what's underneath. And so both of these images are showing the unpressed button. But what I did for the pressed version is I just lightened these buttons. So when you press it on the screen, it lights up a little bit. But there's just 2 screens in this, and it uses crops and the capabilities built into the button feature to give it the animation.
Copy. Thank you.
Mhm. Here's that gauge demo that I was talking about. This is one of the first kind of practical things. I was helping Rick with this. It's got a text field here that can be updated by the propeller. This is a slider that controls this position here. These are buttons that will also do this. Now, the thing about the slider is that the 0 position is right here. But I wanted that 0 here, and I wanted to go 240 degrees like a standard Dynamixel actuator. So to do a little bit of math, and then I'm only using this line is from the widget itself. You'll notice there's a big void right here. The gauge object is square, and it will cause flickering if you put anything underneath it. So that's one of the kind of problems, you know, people have with it. And I'll show you that other TAC project that has a similar kind of range on a dial, but is using pictures instead. So again, another way to solve that. But this is using the NEXTION gauge object. You know, I did this thinking, oh, hey, we're going to be talking about holiday lighting. And then I looked up Hanukkah. I'm not Jewish. One of my best friends is. And then, oh, darn, Hanukkah is going to be finished by the time we get there. But I still included this project. This is page 2 of the Hanukkah project. The first one is just a greeting that says Happy Hanukkah. And when you click on that, it comes to this page. Now, in this case, there are actually 4 screens with the menorah. There's one that's completely blank, that's nothing is on. And then there are 3 more screens that have the candles, and they have different versions of the flames. And this project will, when you light a candle, if you will, and for those who understand or know, with the menorah, you light the center candle. It's called the shamash first. And then on day 1, we'll light this candle. On day 2, we'll light this candle, etc. So this code actually forces you to light the candles in the right order. It won't let you light them out of order. And then it will tell the propeller or whatever else you have connected to it which candle is lit. And then what it will do is it uses a timer. Remember, I talked about that timer will fire and you can run code in it. And what the timer does is it runs, I think, every 100 millisecond, and then it randomizes through the 3 flame images. So what you get is flickering flames. It's easy, you know, but it looks nice. It's one of those kind of little things that adds to the display. And it was fairly simple to do. This is the analog project we talked about. So this is where we can, you know, read a potentiometer from the P2. We'll display the voltage here. This is that XFloat object that I talked about that is a number, but you can insert decimal points in it. And then this is the voltage. So I've scaled this display. So from here to here is 3.3 volts. And this will, you know, oops, scroll. I went the wrong way. This will scroll. The new values show up on the right-hand edge of the screen and push it off to the left. So this is 3 pages of a project. So I can show you various aspects. So this is that one that I kept talking about, Carol, with the LEDs on it. So you can see here's the LED off, and then, you know, the LED is on. So this particular project has 2 pages. It has an off page and an on page. These are text fields, and you can change their color, as you can see here. So I have when the timer is running, I did this as a demo for my friend Dexter, who builds escape rooms. So this is an integrated timer, so that you can, you have to ultimately figure out the code for the escape room and enter it in here. The code that you're entering shows up there. And what I did was every time you press a button and you're wrong, it sends a message to the propeller that says tries equals, and it'll tell you how many times you tried. Because the idea was that if you made too many mistakes, you could be penalized. So there's a way for the propeller to send a message back up that locks out the keyboard, and it changes the display to yellow so that you know you're in timeout. And then guys my age will understand why I use that number. And this is, you have succeeded, you put in the right code and pressed enter. So it unlocks and it changes the display to green and stops. This is a little bit more sophisticated project, but you see, I think it looks nice. Now, one of the things that I did with this, I have I use an Android phone, and I have a calculator on it that has buttons that look like this. So what I did, as I was talking about earlier, is I did a screen cap, kind of like the guy, with the iPhone, pad. I screen capped from my Android phone, brought that into Inkscape, and then copied it. So I made buttons. So these are animated. So when you press them, they actually look like they're being pressed in, and you'll see that. So this one is, I think it's quite a nice project. My friend liked it and I like it, and it shows what you can do if you spend a little bit of time. And there was a discussion about this in the forums. It does take a little bit of time to do this. I won't lie to you, but I work all day and at night to unwind, I like doing technical art like this. I love playing with Inkscape and doing these things. And, again, we're visual beings. We take information in. And I think when I look at this versus just using the regular buttons on the NEXTION, this is just more appealing to me. And if I wanted to make a commercial product, this one might be a better sell. My friend John, I keep mentioning, he's adding the NEXTION to, a future product, and he's worked very hard making very nice displays so that it looks as professional as all the rest of the product that he's building.
So John, can you change the color of the text field in real time, or is that the reason
Yes.
you have 3 full-sized?
No, you can. No, these are just showing different times of running. It's counting down and you're entering text. This is you're in timeout. And this is you've entered the correct code. And it changes. So yeah, there are attributes that you can change in real time. The color of text is one of those attributes. I'll show you how.
Copy, thank you.
This was a project I was mentioning a few minutes ago that will compile, but it won't fit into the memory of the basic display. So you notice this is a very nice looking tachometer gauge. This is built using 218 images. So he, figured out what resolution he wanted for the needle, and so he's just setting a picture image, and this is why he gets this very nice looking needle. Now, it takes a gigantic amount of resources to do that. These other things, so like this temperature gauge and this fuel gauge, these are just image files. So are these. Now, these two images that let me go here first. These are progress bars. So you just have to scale. If let's say your maximum temperature was, I'm not a mechanic, so I don't know what the normal high temperature would be, but let's say it was 350 degrees. You would take whatever your actual temperature was and scale it to get 0 to 100, because a progress bar works in the 0 to 100 range. Excuse me. This image here has 2 copies. It has the white version, which means the temperature is okay, and it has a red version, which means the temperature is high. In the project that was made available, there's a timer running, and the way this is supposed to work is that you serially will change this limit, and the timer then, when it fires, will automatically check to see if the temperature is okay. If it is, it shows the white version of this image. If it's high, then it shows the red version. The fuel gauge works the same way, where if it gets below 10%, this little fuel indicator changes to yellow. So the way that he did that is he has a picture there, and he's got 2 versions of the picture, one white and one, this one is red, the temperature, this one is white and yellow. Now these, the check engine, the battery, and the oil, these are just one image that's placed on the screen. And so what he is doing is serially using the visibility indicator. There's a command where you can just say, hey, don't show that widget, and it turns it off. So there's a couple of approaches that are being used here that are different than what I was doing. So this is, yeah, this Bang Jam means this is not a Johnny Mac project. Somebody else did this. I didn't upload it, but I will if people want this file.
I was scratching my head on what that meant.
Yeah, not Johnny Mac. I didn't do this. I don't like to take credit for anybody else's work. Okay. Oh, this is my normal P2 stuff. We'll talk about this next week. So let's get into this. That was a little longer than I'd hoped for, because I want to actually show you how to use the NEXTION editor. And I guess I should turn it on. Do I not have it? No, I don't. Okay, so can everybody see that I'm running the NEXTION editor? Yes, okay, Stephen's nodding, so this recent projects, oh, I move things around. Let me just open it from where it is. So this get started thing, this is that first display. So if you want to, we're going to go a little more quickly, so we won't make you do this, but this is the starter project with the default names. Now, people know, most of the people, unless you're new, know that I'm an anal retentive nut when it comes to style of programming. So I don't normally use the default NEXTION names. I will rename things, as you'll see in some of the other projects. So these are the default things. So this is a text object. And let me see if I can move that out of the way. So here, if I click on the text object, I can see the object name is T0. This is the first one I added. And then here are the various attributes. I've got a solid color behind it. The PCO is the primary color, so which is the foreground color, so that's black. Now again, this is 16-bit color, so if I wanted to select something different, it'll give me a list, but if I click on select here, then it will bring me up to a chooser. So if I wanted to make it that green or a blue-green, I could do that, and it will change that there. Oh, I fouled up the background, didn't I? I want a solid color. There we go. So you can change your images here. So Carol, getting to that point that you were asking about, you notice how some of the attributes in this display are green, like the font, the background color, the foreground color. Any of these that are green can be changed on the fly. So it means through the serial link. So you can change the color of things, the background color, you can change its positioning, etc. So, you know, right now, this X center means, you know, where is the text displayed within the field? If, for example, I change this from center to right, it will move it over there, etc. So you, and I don't know why that needs to be updated dynamically, but there it is. I guess you could. Same thing with the Y center. If it was, I guess if I drag this box and made it a bigger box, you can move it up and down within there. Let me see if I can Control Z out of that. So that's a basic text box. You'll notice that, you know, I wouldn't normally do this obnoxious kind of thing with this solid background, but yeah, that's the way it defaults. If you do an image, then it will put an image into that box and the text on top of it. So you really need to have your image set to the same size as your box. Crop image is a feature that we'll use a lot, where if we have a screen image, then we will crop that section of the image and use that as our background. Does that make sense? So where the transparency is. In this particular case, I think if I select crop image, it'll work the same as if there's no image there, but there is a background color. So you can see I just have the text on there. That's no longer a good color for the display, but you can see what I'm getting at. And I use that crop image effect quite a lot in my projects. This is a number. It is very similar in the attributes in that you have a font, foreground color, background color, alignment, etc. This, oh, sorry, let me go back up to this. You'll notice here, this is where we're putting our data in the .txt attribute. In a number, we have a val attribute. So if I change that to 1, 1, 2, 3, then it will change that value. This field is that X float. It's the same as a number, but you'll notice it has these, it looks like WS, it's actually VVS0 and VVS1. VVS0 is how many digits we can have on to the left of the decimal point. The more interesting one, of course, is VVS1, which is how many digits to the right. So you can see that's just one now. If I wanted to display, for example, the ADC from the propeller, which is going to give me 0 to 3.3 volts, I would certainly change this to 3. And now I have a display with 3 digits there. Here's the progress bar. The progress bar has foreground and background colors that you can use. Same with, this is this slider. So you can see here's the thumbnail, the background, you know, this is the on portion and the off portion. These are very garish colors, but these are the standards. Of course, they can be edited here. This is a standard button with kind of a normal 3D effect. You'll notice within the button, there are various versions of the button. I use the standard 3D auto. This, somebody's knocking at my door. I'm assuming it's a delivery. I'm going to ignore it. This is a 2-state button. So this is press on, press off, but the attributes are very similar to the button. These are check boxes. So they'll be those square dots. When they're on, they have a black dot in there that's square. And these are the radio buttons. They are the same. They're same thing, but circular. This is a picture. And now you notice I have pictures in in my project. So of course you want to have any pictures that are going to be placed in here should be the same size. I haven't tried to break it by using a different size, so I don't know honestly what happens if it tries to scale it, or if it's bigger than your area, if it crops it. I don't know. I didn't do that. So I think it's just safe if you have I think this is 130 by 130. Yeah, you know, so make your images 130 by 130 or whatever the size you choose for this. And so you notice here, there's a PIC attribute. So that's going to correspond with the ID here. So you'll need to be aware of that. In that graphic tachometer project, there's an offset. So he has to know about that when setting his image. So be aware of that. And down here, this is a hotspot. Now nothing is going on because this is a blank version of the project. So nothing happens. What I'm going to do is I'm going to open the one that has the serial stuff built in. No, don't say that changes. Which is the -1. So this is the same thing, but this has events coded into it. And so let's look at those, and then we'll let's watch it run, and then we will go. And so if I click debug here, this will bring up the simulator. So now this is as if I'm running a live display. Notice that, you know, what I've done is I've linked the this slider to this number, this X float, this progress bar. And what I did is on the release event, I sent a message, and this is showing the message in hex. You can hover over that and see the ASCII, but if you click on this S right here, it will show you the ASCII version. So what I've done is I've made a really simple kind of protocol that matches the way that you update the NEXTION. So if I wanted to change just for fun, this text is normally based on position. So you can see how that's changing depending on where I go. But I can manually change that text by saying T0.txt equals parallax rocks. And do that. So This is serial input. So I could have sent that from my propeller. And now, of course, that'll get obliterated by my events there. But you notice how they've made a really kind of simple text protocol where you have an object dot its attribute equals, and then whatever you want. It's very easy. Now, what is not showing here that you'll see in the propeller code is that you terminate a message to the NEXTION with adding 3 characters that are FF, FF, FF. I don't know why they do that, but that's what they do. And so, for example, this is the output from the NEXTION. If I say t1.txt equals John, which is valid syntactically, but I don't have a T1 object. If I go now to the hex, you'll see that it's saying 1A FF, FF, FF. So that's a system message from the NEXTION. And so I have code, we'll show you in a minute, that does handle those. So in case there's an error. But you'll notice that the NEXTION by default wants to output the FFFF. What I've done for these things, you know, when I do click and all that, is I've decided to override their normal output for my own. So in this case, when I turn this on, it says show pick equals 1. And then it may be hard for you guys to see, but on the end there, it says \x0d. So I'm adding a carriage return. So I'm terminating my strings going to the propeller with a carriage return. The reason for that is then you can open up a terminal and you can just see the stuff coming. Now, you can't really, from a general terminal, send stuff back because of that FFFF thing, but I made a program that is in the code base that runs a terminal, if you will, through the propeller. So when you start typing, it accepts that and it'll send the message and it will drop the FFFFF into the message so the NEXTION understands it. So again, these things are all, you know, they behave the way that you expect. Again, with radio buttons, the NEXTION doesn't do anything with this, so I've coded this. I'll show you how. And you'll notice that when I change the radio button, it affects this picture. And it also sends out a message that says stooge equals and the name of the person in the picture. All right, so let's look at how this happens. When the NEXTION starts up, there's a couple of things it looks for. It's hard to see here. There's a tab here. This is the globals page. Normally, you don't have to do anything here, but you may want to change the baud rate. Now, I set mine back to the normal because I'd had it updated, but if you put bauds equals and then the baud rate, that will update the baud rate in your display and it will tell the display to save it. If you just say baud equals, it will change it, but it won't overwrite the EEPROM in the display. So you have choices there. You'll see that on a number of their commands that there's a singular version and a plural version. The plural version, that S on the end, means save this new setting to the EEPROM. So you might do that there. This area also allows you to set global integers as well. If you have a project, you need global integers, specifically if you're wanting to pass values between pages, because there's no, you know, we don't have routines or functions or methods like we normally think about in the propeller or any other processor. This is all event driven. So you would put that stuff here. Now, when your project, this is a single page project, as you can see. Sorry, I'm having to move around my window, my Zoom window stuff. Here I just have a single page. When that starts up, this pre-initialize event, this code will run before the page is active. And there's a couple of commands here that I think are worth talking about. This one, TSW, allows you to enable or disable a widget or an object. So for example, I have this M0 thing here that is I'm using to hold code. It's actually a hotspot. And if somebody accidentally pressed that, I don't want it to fire. So by doing this TSW M0, which is that with a comma 0, that 0 means disable this from being touched. So I can call it, and I do, but I can't touch it. Does that make sense? I don't want that code that's in that thing to accidentally fire if I touch that portion of the screen. So that's what TSW does. I do the same thing here. I'm disabling the radio buttons, or based on this value, this toggle value. So if this toggle value, if this button starts off, these will all be disabled from being touched. They'll be visible, but they won't activate when I touch them. So in fact, I'll show you that again. If I have, so the toggle button is off. You see the gray background? I can click here, but it doesn't do anything. Now, when I click on that, it does activate those. So now I can go through. Okay. So bits to think about as you're designing your user interface. This h0.val equals 0 is setting this to 0. Let me go back. I'm starting with just this radio button on and these off. That's what this section is doing. I'm telling this guy to be off. Since I have this toggle turned off, this is that command I was talking about earlier that is used in the tachometer project. With this sets the visibility. So this object is called P0. So VIS P0, comma 0 turns the picture off. To turn the picture on, I can say viz space P0, comma 1, and that'll turn it on. So that's how you can selectively on the Dash project. That's how they turn lights on and off, is by just disabling a picture. And then I preset this to 0. So this is my initialization stuff. My code is set that way, but I'm very fussy and anal stuff. And so if I ended up changing anything when experimenting, this will just put everything in its place the way I want it to start up. Okay. So this is a receiver, the message, these guys, so they don't have any events, these things, but the slider does, because we can do things with it. We can slide it, we can move it around, we can click on a section and do things. So you'll notice that there is a press event, there's a release event, and there's a move event. So we can deal with all of those events. In this case, if I press it, because this will change, what I'm doing here is I'm calling M0, comma 1. So that's calling the click event that is built into this guy. So if I go to that, this goes into reading everything, updating the displays, and then based on the value, changing this. So this is code. You'll notice it looks a bit like C, but there are some small syntactic details that are different. Also notice, since remember over here, there was these, there are 3 predefined variables called sys0, sys1, sys2. They don't do anything. They're just predefined global variables. So I tend to use those as temporary variables. So in this event, in the click event for this guy, I'm grabbing the value and then I'm sending that into here, and oops, I got it. Oh, hang on. Thankfully, that reset layout button lets you fix things. And then doing all of the updates. So this is acting, this seems a little obtuse, but this is how we do subroutines. We stick code into an event in a hotspot. The reason we use a hotspot is because they're invisible. So when you need something that you can run from different areas, this is how you do it. And if we go back to this slider, remember there was 3 events. So with the release event, well, let me go, the move event, I'm also calling that. Now the release event, when we let go, is when I want to send the message out the serial port. So we call the click event, and then we convert that value. So COVX converts a value into a string. So the first thing we put in is the value. The next thing we're going to specify is the destination string. You can see here, I've got a string variable for the page called VA0. The first 0 here says use as many digits as you require. So it's an automatic size setting. And then the last one is saying use decimal mode. Now, the nice thing is here, I'll do this manually. Hopefully this will show up through your stream too. Are you able to see the flyout help that I'm getting?
Yes.
Okay, so it's pretty good about not predictive stuff, but it'll help you with what you need. And so in this case, so 0 means automatic length. So I'm going to use that. And then the last one is decimal currency or hex. So that format. So this is a string conversion that has some tools. Luckily, again, in the editor, they have these nice little helpers that will assist. Also, this text is a little on the small side, so you can do control scroll wheel here to bring it up. I probably should have done that from the start. So this is
Don,
yes.
on using that global variable as a temporary variable, it'll still be global acting, won't it?
Yes.
Okay, so you don't want to use it
Why not?
arbitrarily.
Well,
No.
it's a global, but yeah, I'm using it as a temporary, so I wouldn't want to use that as a feature that needs to be retained. So if I need global variables, Carol, what I end up doing is defining new ones with my specific names. The sys0, sys1, sys2, I use those as temporary variables. And then know that they could get clobbered screen to screen. That make sense?
Yeah.
You can also,
Sort of.
if I want, I could put a number variable here. It's just for a temporary variable. It doesn't seem necessary. And then you have to do the name.val. It's just a little more typing. So I tend to do that. For temporary variables, I tend to use a sys0.
Yeah, I think what the point she might be trying to make is if you use that temporary variable for different objects, you didn't really want to, and you get a really weird side effect where you change the number and a bunch of other things are changing in ways you don't want them to.
Yeah,
Well,
rather than like a local variable that will only
Right.
do the one thing you're targeting.
So you gotta be, yeah, so you just kind of have to be careful how you use it.
Right. Yes. Yeah. We're all programmers and we're adults. We know how to do these things. So you could, Carol, you're absolutely right. You could put a local variable on the screen. For numbers, it's a little, for me, it's a pain in the neck because I don't like doing the .val thing unnecessarily when I have variables. So you wouldn't want to willy-nilly say something equals sys0 without knowing what's in sys0.
Right.
But if you want to pass values between pages, that is one way. Again, if you know that, you can do that. But as I said earlier, I tend to, if I want to pass values between pages, I will define my own variable. So for example, if I wanted to put another value in here, another variable in here, I could say key value. Oh, sorry. Int key value equals 0. So now there's another global variable called key value. So if I called a keyboard page, I could set that. And then when I go back, that's where I would get it. Because there's no direct, again, this is not a standard programming language. It's an HMI. So we're going to be doing things a little out of the norm from our other programming practices. But both ways are valid. You can use a global local variable. In this case, I tend to use these three predefined globals.
Oh, the local variables are local to a page.
Yes.
And what do they look like?
If I go back there, you can see, so here's one here.
Ah,
I have that. So if I wanted to create happens to be a string. So you can see I've got VA0 and it's set to a string mode. If I go to the over here to variable and I add a new one, it defaults to number. So now to use this, I would say va1.val. That's how I would use that. So it again, 6 of one, half dozen the other, both work. It's stylistically choose how you want to proceed.
thank you.
Mhm. The other thing too, we'll get in next week more, you can set things on screens to be global so that they can be changed from other screens. So there are some attributes you want to do that with. I have a demo I'll show you next week where I can, before I go to a page that's an entry page, like a keyboard entry page, I want to set the title on that page before I go there. So I make that text a global variable. And the way though, you notice I just have one page in this project. If I have multiple pages like I'm talking about now, where I'm going to go from one page and I want to call a keyboard to do some entry and then come back, what I would do is I would set the text on that, if you will, the subroutine page. I have to identify it by using an internal array that is in the NEXTION. There's an internal array called P that is the pages. So if let's say that this is on page 1, this is page 0, but let's say it was on page 1 and this is T0. From another page, if this was global, which I can go here and I can set, you see where it says vscope? If I set that to global, now from another page, I could say P square bracket 0, close square bracket dot T0 dot TXT equals something. So that allows me to set this text from another page. We're getting kind of into the weeds. I will show you that later. But yeah, there are most things you're going to treat locally, but with some exceptions, you can globalize things so that you can make a nicer interface. All right, where was I? I was on this guy. The release, again, this converts this number to a string and now I print it out. The print statement will send it out. Now this I could have changed. 0 almost always in this context will mean just use as many characters as you want. Since level equals is a fixed value, I could, that would have been smarter, just put 6 there. It means less work for the display. Then this will print out the value, and then this prints the carriage return. So this is a language out of the NEXTION for me coming into the propeller, the way that I can put stuff in. Again, if we go back and run this, I can tell the display T0.txt equals, oops. And it will change that. I use this same format, the widget equals something. For myself, I have an identifier that I'm going to use in my propeller code equals something. And I'm using that in my projects. John's using that in his big project. We've added a little, additional feature to it, but I'll show you that code. Let me show you a couple of other things and then we can get into the propeller side. So this, well, I've gone through all of this code. I want to show you other projects, but this has kind of the meat and potatoes of what we're going to do. This is how I'm sending data out of the NEXTION and into the propeller. Again, with sending it from the propeller into the NEXTION, you can see how that worked from the simulator screen. So let me go through a couple of these other ones. So we can-
John, can I have one more question before you move project?
Yes, go ahead.
The names of the widgets.
Yes.
Yellow squares. Is there any way to get rid of those? They're really annoying.
Yes, there is. And yes, there is. And I don't remember how, but I'll find out and I'll put it in the forums.
Thank you.
I did that accidentally. You're right. Sometimes it is kind of a headache, but it is nice to, I guess, you know, technically, if they're not there, you can click on the thing and it will tell you there. Now, there is there is something to be said, and I'll show you in a couple of projects. You notice that each of the widgets or objects has their own identifier. You cannot edit this. If I can try to change that, it won't. The only way that you can edit it is to use these up and down arrow keys. You can either push it to the top of the stack or the bottom of the stack. There are cases that I'll show you in some of the examples where you want those identifiers to be in a contiguous order so that you can loop through them in a string, you can iterate through them in a loop, or you can do other things. I'll show you that in a minute, but I'm sorry that I don't remember how to do that off the top of my head, Carol, but I'll remember it and I'll post it.
I appreciate it. And so that's actually a draw order is what it is. If you were to
Yeah, it is, but it's also, remember I just told you that there's a built-in array called P that gets you to a page. There is also on each page, there is an array called B, which is the component. And so you can iterate through components where you can use a component by its name, or you can get to a component by saying B square bracket, the component ID, close square bracket, and then whatever the attribute is after that. So we'll see that in a couple of the things coming up. It'll make better sense. So there's those two internal arrays to be aware of. All right, let's look at some more exciting projects. Oh, here's one that I can display. So here's that analog in project that somebody in the forums had asked about. So this is the waveform object. It has up to 4 channels. I only have 1 in here. So the CH is the channels. You cannot change this on the fly. So, you know, so be aware if you're going to do a project with a propeller where you may want to have more than one thing, you know, where the propeller decides how many channels to display, you should probably just set this to 4, because if you don't add anything to a channel, it's not going to show anything. This is the background color of your grid, the grid color. These are the gradations. I don't know why well, they let you change this on the fly. I wouldn't do it, but you can. And then this is the display color. So on this particular project, you can see I have a graphic background. I'm old, so I like brushed aluminum. So here's my background. And I put a little inset kind of thing in it just to make it look physical. And then on top of that, I have text here. So this is a text object. This is a text object just with right alignment. And then this is the X float. If you don't know what something is, if you click on it, if you click on the type here, it just has a number, but there is a little helper, so it'll tell you what it is. So I know that that's an X float. One of the things that I did not show you, because we've got text in both of these things, is how to add text in. You'll notice here, if I click, this is the resources that I've got embedded in my project. There's a fonts tab, and here I've got a font called Consolis 32. Here's an interesting thing with the NEXTION that I ran into. I frequently use Inkscape, so I'm going to click over to Inkscape. Can you see my Inkscape screen?
Yes.
Okay. So I'm going to open one of the projects that I had. Let's see. I think I had I thought I had the timer one that I did. Is that it? Don't know. Could be, this might not be, nope, that's well, let me just do this. I have, well, darn, sorry. This just makes better sense if I open up. So you see it.
I'm curious what kinds of applications people will be using the display for.
Yeah, that's why I'm trying to do a bunch of different things here so people can, see it. Oh, okay, so here we go. So here's the resources for the escape timer. Here's my Inkscape file. And of course, Inkscape crashes. I didn't pay anything for it, so I can't complain. Okay.
John, while you do this,
And-
I'd like to know if anyone's doing any solar panel renewable energy applications with Propeller. And I think, Carol, you said something.
Oh, I'm gonna change to what you just said. I have several size solar panels, one of them being a 24 watts. So that might be good. It runs
Might
an
make a
RC
good
car.
project.
I did make it a long time ago into a project from Mind's Eye. Made a solar powered RC car.
Are you trying to power your boat, Ken?
No, I don't have any any specific in mind yet.
How's the boat going?
The boat's
Let's
stalled.
talk about that at the end.
Yeah, go ahead, John.
Okay, all right.
Yeah, we tend to go off track, and I'm already way late. This is my Inkscape project for something I'll show you in just a minute. So Inkscape, like a lot of other editors, it's layered. So I have a layer in here that I don't save out for the NEXTION, but it just shows me where I want my displays to be. And so if I look here, I can see what the font is and the size that I'm using. What I found is that this size doesn't correspond to what is in NEXTION. So beware of that. So this is a strategy that I use. I will create an extra display because I'm sketching everything in Inkscape. So this is what I want the panel to look like. So I create this background. I load this in, then I create a font, hoping that I get the size right. If not, I'll create another font until I get it adjusted. So be a little bit aware of that when you create a font in the NEXTION, it won't match what Windows or other operating systems, how they what am I trying to say? Display it. The sizes are going to be off. I don't know why. The NEXTION are always about 35% smaller. So here in this case, it says 56. So I would definitely choose a larger font size in the NEXTION, hoping I get that close. So it's something to be aware of when you're designing nice displays like this. So as I was saying earlier, if you have a text or a button, anything that requires font, you need to do that first. So the way that you do that is you go into the Tools menu and click on Font Generator. It will bring up this dialog where you will select your size and then whatever font you want to compile. I'll just grab one. You can give it a name. So this is going to be an internal name. What do I call this? I'll just call this OCR. I tend to do this. I use the name underscore and then the size that is here, and then generate the font. And then it will give you the opportunity to save it. As you can see under my NEXTION folder, I have a fonts folder where I've saved a bunch of other things, and I'll give it the same name there. So I'll just say the OCR 40 and save it. And then it will, so here's the thing. So I said 40 and it says, no, it's 35. I don't know why this is. So you may have to go through a couple of tries to get the font the correct size, because you can't scale it after it's generated. And then it will ask you if you want to add it. I'm going to say no in this case, because otherwise it would add it into my project. Now, this is one of those kind of niggly things. You have to have a font for text and for buttons. If you want to change the font, then what you do is if I want to change these, then I have to add in the font, and then I have to go to each of these things and then change it here. If I then, as I was saying earlier, you want to clean this out. Don't put resources into your project that aren't actually being used. So then you can delete it. Luckily with the fonts, it's kind of smart about that. If you had 2 fonts in there and you deleted one, it would automatically realign your objects to the font you're using. But it's a niggly thing, but as you can see, I already generated a bunch of fonts for the various projects that I'm using. So here in this case, if I run this in the simulator, now I can do this. I can say title equals title.txt. Remember, these are objects. And I can say label.txt equals volts. I'm going to make this so that the P2 changes it. And then away we go. Now, to put data onto the waveform object, you have to know its ID. So I happen to know that the ID of this is 1. So what you will do is say add, and then the object ID is 1. I only have 1 channel, so that's going to be 0. And now this is 220 pixels tall, so I'll say 110. You probably won't be able to see it there, but there's a little dot right there. So what I'm going to do now is what I had talked about a moment ago. I'm going to go over to my propeller and use the waveform. So here is, we're skipping ahead of code, but this particular project will create a serial link at the baud rate for the specifying there. And in this case, if I have simulate, yes, I'm using the programming port. Otherwise, I use the hardware port. And then you can see I'm just sending strings to the NEXTION display, the same as I was typing them in. Now I have formatting built into my serial object. So when you notice, remember when I did the strings here, there's double quotes around them. You have to do that for text. So when you're sending that from the propeller, the way that you're going to, since I'm using a formatted string, this hex 22 is a double quote. And so I'm doing that. And then this %3C will send 3 characters. This is the only attribute that I'm adding here, and that will do that 3FF thing. So after I've instantiated the serial link for the display, this sets everything up. So this sets the title label, the label text, this VVS1 for the level, that the level is the number. That's telling it to use 3 digits after the decimal point. I preset the value to 0 in case there was something in it. And then CLE will clear the display. So once this goes, we'll get our text on the display, zeroed out the value, and a clear window. Then when the program runs, it's just running in a loop. Quickly, I'll go through that. What I end up doing so that I don't have noise showing up in the display, this V is an accumulator, if you will. So about every millisecond, or just shy of a millisecond, I read the ADC and I accumulate that 16 times, and then I divide it here. So I'm just taking an average of 16 samples of the analog line. And then I'm sending this to that number on the display. So remember, that's the level widget. So level.val equals, and this %D will send that voltage value. This G is for the graphic. Now remember, we have 0 to 3300 on our ADC, but we only have 0 to 219 on the graph. So this scales that. So this takes the volts and scales it between 0 and 219. And then this adds the channel. So the rate at which the display change is going to be based on this loop speed. So I set the loop to run every 22.7 milliseconds. And that means that the display will scroll through in about 10 seconds. So what I'm going to do is I'm going to download this program to the propeller. So it's now available and running. If I go back to the NEXTION in the simulator, and if I say use MCU and start. Oh, the reason you'll notice that the display is running. Since my throat is killing me, I'm going to ask a question to make somebody else talk. Why didn't my labels change? It's because the simulator was already running. Here, watch. If I reset the propeller, now they do.
Huh.
So now I have a display that changes about every, from right to left, it scrolls in 10 seconds.
That's a super example, John.
See the value? I thought you'd like this, Ken,
because I understand it.
But yeah, I'm just turning a pot willy-nilly and you can see the display there. So I have another version. We can just leave this same, now I need to stop this so I can program the propeller, because remember, this is using the same serial link. So if I go here and I have one called Heartbeat. I'll run this. So this is using the same display. Sorry, and since it's running now, I'll start the display again. I'll reset the propeller, and now it says heartbeat. And now, hopefully, so I've put my finger into this janky sensor that I got from. So there we go. So now you can see my heartbeat. That sawtooth wave is actually corresponding to my heartbeat. Now I don't know how to offset all of the regular DC in there. You see I move a little bit, it goes all over the place. I've been playing games with filtering, but again, the reason I'm showing this is I've used the same display. All this code, the only thing it did, it just changed the labels. And you'll notice how, now I'm not actually calculating the heartbeat yet, so that BPM is not going to change, but you'll notice that the decimal point is gone because I can change that decimal point capability on the fly. You can see I move and there's all kinds of garbage. I'll do one more using a similar display. Let me turn this off.
John, could you say that once you know the ins and outs of using this this tool they have and using the display, that it's a lot faster to do this with their GUI than it is to write code for like some of the other displays we've used?
I
Where
don't
does all
know.
that land?
I suspect it is. I think you can get higher quality visuals from this because you can use graphics tools. Like, John uses AI, I use Inkscape, but you can make really nice looking displays. It would be a little hard to code those kinds of displays. Like Ray Roddick did a nice display driver for, TFT, but those are just doing lines and boxes. So you're going to get very flat looking displays. This, because we can do, this is, I'm not an artist. My brothers are artists. I'm not. I'm an amateur with this stuff. But this looks reasonable. The brain will accept that as kind of dimensional, even though it's flat. So, for me, again, I live here in Hollywood. It's about art. So I like to do technical, artistic stuff. Certainly don't have to do this, but I like that you can with this and you can make really attractive displays. So let me show you. Go ahead. I'm going to open.
I use processing for that, and I think it works really well.
You can do a similar thing with that too. The difference is that this, I'm showing this on the PC, but ultimately it's going to be deployed on this and in my handheld project. So this is not about, I'm doing it on the screen in simulation just for testing, but I don't think you were in the beginning of the meeting, Carol, but the whole idea though is to get it to work on this physical display that I can carry around. So For example, I work for a laser tag company, and I'm working on a project where I can carry around and I can control the game with this touch screen, or I can analyze the RF, by going to a different screen within the system. So the stuff that I'm showing you on my PC is simulation for testing. It's not for actual display, but you're absolutely right. Processing, if you're wanting to run it on your PC, that's a great tool because you can do those things. You can use, I haven't done a lot with it, but you can use SVGs right in processing. Here you have to, I'm using Inkscape to create my files, but then I'm compiling them, if you will, to a PNG that I put into the display. So this,
I like with processing, you directly download your data strings to it and have a live, very quickly have a live screen of a
Right.
waveform or whatever.
right, we're doing the same thing here.
If you want to haul around a computer.
Yes, exactly. Processing is great for running on your PC. This is ultimately going to land on a physical display that I can carry around. This is, you notice the same screen. What I have in fact, if I open the Inkscape project for this, so here's the SVG. What I did, since you can have up to four channels on the waveform. What I did is I created 4 windows, and those are just set in layers. So I've got all of them turned on. In this one I'm about to show you, oops, select the wrong ones. I wanted that one on. So I downloaded this as my background image. And, again, I'm not a graphics artist, but I can read, and, I'm doing things so I can make things really, quickly and easily. So on this particular project, because Ken and I worked on this, some of you know, and Ken certainly does, I used to work in the golf course industry. So temperature and weather and that stuff is always appealing to me. So I'm going to download this. This particular piece of code reads a DHT22 temperature humidity sensor. Now this won't be quite as exciting as that last one. If I turn on the simulator and say go, and then reset it so that it updates it. Oh, sure, I put a bug in there. Great, this worked yesterday. What should be happening is that, let me just make sure, hang on, I put the right code in, because there's only one thing, one channel. It should be showing 2 channels and not that quickly. Doggone it, John. Propeller tool. Did I say, oh, I put in the heartbeat thing, sorry. Trying to do, there we go. The temperature, if I ran the right program, it would be helpful. Now I'll restart this. Sorry, gang, getting ahead of myself, and turn this on, start that, and reset the propeller so it cleans everything up. So now you can see on my desk, it's 79 degrees with a humidity of 53%. It's always warm in my desktop environments. Could be, I guess, this hot-blooded Irish guy right in front of the sensor. But if I, this is gonna look funny on screen, but I blew my breath onto the sensor. So you saw the humidity just jump up. Now, this is a slow display. It takes 15 minutes, so we're not gonna wait to go all the way across here. And that's a function of this sensor. The DHT22, you can only read it you're supposed to only read it every 2 seconds. And so since between here and here are 440 columns, that works out to be about 15 minutes. But here's how you do a dual channel display. And you can go up to 4 with the graphing component. So I don't remember, forgive me, the person who asked me to cover this graphing component, but I hope that some of this makes sense and you're able to then do the other things with it. I knew, Ken, that you would like this because of the things that you do. So it's a nice project, a nice component.
Well, I gave that sensor a really big workout last year about this time.
Yes, yes,
Remember?
you did.
Yeah, it made you nervous.
Well, you were shooting it with a flamethrower and then dousing it with ice water. It was a little tricky. Let me show you some of the other projects and then we'll go through the code so we can wrap up. Open. So this is in the waveform folder. And now these are some of the optional ones. There's code for these two projects. Let me go with the gauge first. This is one of the first projects that I did. This was helping my friend Rick. Result layout. So the thing about the gauge object in the NEXTION, you notice how it takes up this big square. And you see here where 0 is at 9 o'clock. So knowing that, I have some code in here so that when I change this, so when this gets changed, the release, it calls HS update, which is again, so in this case, you'll notice I'm using better names. So HS is my preface for hotspot. And then update means we're going to do something. So in this case, because of the direction of the gauge versus the direction of the slider, this first line just reverses that. And then because this is 0 degrees here and it goes all the way around to 360 here, this will figure out that thing and readjust the position. I'm not going to get into great detail. I'll show you how it runs. And then what I'm doing in these cases here, you'll notice again, this looks kind of like C, but these are changing colors and I'm using specific colors. There are some color constants built in that you can use, but let me show you when I run it, it'll make better sense. So if I slide this, it will go, and you notice how the arrow changes in between. And I can nudge it with these guys. And then this text, I think it's called label. I tend to do that. Equals. This was for a Dynamixel test, but it's not called label because, so I know that 1A means, hey, that variable doesn't exist in your system. So I don't remember what it's called, but what you can change that, of course. So this is the gauge. Again, not my favorite of their devices, but there is code here to explore. And you notice here's my transmit thing that sends a new value. You can see I was helping Rick, so we were sending it to a P1. Doesn't care, it's sending it out, and it's sending it as a string. You'll notice here's that same strategy. So repeating myself, my strategy when I want to tell the propeller what's going on inside the NEXTION is I say something equals and then some value with a carriage return after that. And then I have a parser, which I'll show you in just a bit, that handles the values from there. All right.
Hey, John, is that scalable so you can run multiple gauges on one screen?
You can. You can have as many gauges as you want. You just have to be careful, Josh, not to overlap them because it'll cause a weird flickering thing. So if you don't need a lot of resolution in your gauge, doing it with images, which I'll show you in a project here in a bit, will make sense. Here's the menorah project that I told you about. Now, I kind of like this. So when we run, oh, there's compile. I know it'll compile. Here's running in the simulator. So this is what would show up on the screen to start with. If I walked up to this touch screen and click it, then I get an empty menorah. So again, in the tradition, you would click on, you would light the center candle. So hopefully you can see that through the stream, but the candle is fluttering a little bit. And you'll notice I can click anywhere, but it knows where I am, and there's a state counter in there, so it will only let me light the correct candles in the correct order. And every time that I do that, it will send a message out to the host that tells me what my state. So For example, a long time ago, I was asked by somebody at the California Capitol grounds to write a menorah program for the basic stamp 1. This would be a little more advanced version of that, where you could control it with a touch screen. And so this is using a timer object to do this flickering. I think it's a simple display, but I think it's quite nice. What I was talking about earlier is here you can see in my resources, I'll go ahead. And if you click on the Star of David, it sets the state to -1, which means we're done, and it goes back to the greeting. So this is a multi-page display. So you can see here, when I want to, if I click on this, you can see I can change to another page simply by saying page and the number. In some cases, you can actually use the name that you've given it. I don't know if it'll work here. So you see, it knows that. Let me run this and see if I'm lying. Yeah, so, no, it didn't work. It knew it, but it didn't accept it. So I'm going to go back. That's probably why I didn't do it before.
Well, I think you changed your page to the page that it was on.
Well, here, because I want this to go to page 1, because you'll notice here on the menorah, there's a hotspot over that image that will send out this state message and it goes back to page 0.
Yeah, but instead of saying page 1, instead of saying menorah, you said page 1 or greetings when you just tried it.
Oh, so I was on the same page. Sorry.
Yeah.
I'm tired. Yes. I'll try that offline. This is generally the way you see people doing it, but you can name your pages. So it seems like it would make sense, in making this code on this, in this event easier to read. You don't have to go look it up. So here is in my compile things, you can see here's my menorah off. And then I have 3 different versions with candles, and those are just different flames on the candles. And then when the program starts, it's on the initialization code for this screen. There is a command called rand set, which will let you set the range of the randomizer. So in this case, I have 3 images that I want to select, 2, 3, or 4. Those correspond with these images here, 2, 3, and 4 with the different flames. My hotspot, remember this TSW means I can't touch it. I can only call it. And so, excuse me, when I'm in the page, when the timer activates, so that's the flicker timer, what happens is this is going through, it's iterating through the different candles, and it is checking to see if my current state value is greater or equal to that particular candle. Here's where I'm making the candle flicker. Remember, I told you that on each page, there is a B array that is the components on that page. So I have 3 images that have candle flames on them, and they start at 2. So that's why there's this 2 offset in here. And so what happens is that this is going to select the candle and then a random picture from these 3, because that rand set that was on the first part of the code here, this is limiting the value from rand between those 2. So it makes things easy if you have a singular random value like this. If you were going to be using different random ranges, then you'd have to do a little bit of coding to deal with that. In this case, I didn't, so it made it really nice and easy. But you'll notice here, if I click on this, I have so here's where I am, Carol, getting to your point. I am using internal variables, my temporary variables, because I have more than one. So this is saying when I click on a candle, I set the new state. So you can see I've got crop elements here. I'm setting new state.val to whatever that candle day is, and then I'm calling HS update. So this is my updater, and what it will do is this just ensures, this code here ensures that that candle is eligible to be clicked. And if it does, then it sets my state to that, and it sends a message out that's saying I have that, I'm at a new state. The timer is what takes the state value and animates the lit candles. So that's a good use of I think it's a nice demo of timer object. Oh, here's the very easy project. This is that passcode project. So Carol, here was that thing I was telling you about. So there's just two screens. There's everything off and everything on. So when we run this and put in, because I'm old and I love this song, 8675309, the young people will have no idea what I'm talking about. You can see one, and now that it's unlocked, I can click anywhere and I get back to the original state. But you'll notice when I click on a button, now I'm holding my mouse down, you notice how the button changes, it's highlighted, and then I let it go. And the way that happens is by using a button, and I've got it in image crop mode. And so when it's unpressed, it's showing this image, what's underneath that section of the crop. And when it's pressed, it's showing this image where I have things highlighted. And you'll notice also here, I have crop objects above all of these things. And then the state variable will loop through using that B index to set the number of these that need to be on. And if you enter a wrong code, again, this is kind of cheap and easy. You always have to use 7 digits. If you enter the wrong code, it will just clear automatically. And then once you get it right, it does the unlock.
Can I ask a quick question about the menorah?
Yes.
If you wanted to use it, say have put a computer up on your mantle or whatever, when you, let's say on the second day of Hanukkah, when you're lighting the first candle on the far right, if your computer turns off or goes off during that time, when you bring the menorah back up, will it go back to the candle configuration that you last had there, or do you have to start all over?
In this case, it doesn't. I made this as a simple control mechanism. If I was going to do this as a project, what I would likely do is use one of the other displays that have EEPROM in them so that I could keep track of that. I would probably also use one of the other displays, have a real-time clock so you could completely automate it. So if you knew when sundown was in your location, you could put that in, and then at midnight have them cycle off. This is just the goal of that was because I was thinking about the holidays, and like, so one of my best friends is Jewish, so I've been to his home during Hanukkah. And so it was an example to show to do, a little bit of animation. But as you saw, it is sending messages out. So you could connect it to a propeller and then have the propeller controlling lights, as I've done a couple of times in projects. Like I said, the state of California asked me to write a program for the basic stamp, and they were controlling big lights on the Capitol lawn during Hanukkah several years ago. So that was an easy one. One other, here's another use. There, if you spend enough time on YouTube, as I have, looking at various examples, you'll see a lot of dashboard displays for the thing. And here's another use of the crop tool. So what this is kind of a flowy, swoopy tachometer display. This is not a full project. This is just showing use of this internal array. As you'll notice here, well, let me just run this and then I'll talk about it. So in this particular case, there's 20 segments. So if I say new segs, which is how many segments I want lit. Oh, come on, John. Oh, segs. Sorry, guys, I'm a little tired. There we go. And you notice it animated by itself. So this is using the timer to go through what it does when it runs. I'll just, it goes the other way too. Say new segs.val equals 5, and then it will go down. So the way that this works is when you set in that value of the number of segments that you want lit, it will, when the timer runs, this section just makes sure that you don't enter an illegal value because there's only 20 segments and we're using that value as an index into the array of these devices. So you can see here, this B array is taking the segments value. So if I looked on the in my objects, here's the last one, you can see my component ID is 20. So this is one of those cases where when I'm putting things together, I want to do it in order so that this is ID 1 and this is ID 20 and that they are contiguous in between because I'm going to animate them in that direction. Now, if you forget about that, you can get them into order, but what you have to do is use these arrows here and kind of go in reverse order, either push everything to the top and then it will stack back up, or push everything to the bottom in the same way. But you want these object IDs between here and here to be contiguous because those are getting animated in this timer event where it's going through this B array is my ID. And so the segments is these things. So here, this pick determines which picture I'm using. You can't see it here, but if I look on the screen again, if we run it, I've got a kind of a lights out version. I don't know if you can see it through your screen, but I've got a very faint dark gray image of that graph. And then when it goes through. It seems a little slow. Now this is in the simulator. The simulator does run a little slower with the timer events than the actual display. Because there's other stuff going on inside the display, the timer event has the shortest firing range of the timer event is 50 milliseconds. So you're not going to do things super slow, super quickly with the timer event. You could control this externally and just send messages to do that animation from the propeller. Because, again, if you're sending at 230 kbaud and you're doing really short messages, you can blast them up pretty quickly. But this is, I wanted to show how to make a non-rectilinear looking display, because you'll see a lot of this. And I was curious, I saw there's a bunch of race car simulators that are using NEXTION displays that are doing fancy dashes. And I was wondering how they were doing that. I finally got the code for one and I saw that that was what they did. So I made a simpler version to share with you. You could use it for other kinds of displays. Finally, one last one, and then we'll look at propeller code and then call it a day. This is the escape room timer. So this is another password kind of thing, but it's a little bit more sophisticated. In fact, this one, if you had one of the displays with IO, could run standalone. Now, in this case, when it runs, is it not running? So I have this is a very quick escape room. You got 10 minutes to get out. And so I can take a breath and get a drink. What's my valid code for this?
that song, but I can't even remember what the number.
8675309.
There you go.
I got your
Yeah.
number.
That's it. Yeah.
I won't sing the rest to you.
Yeah. Come on. Now what you'll see here is so you see, here's where I was talking about. You notice that if I click on a button, I've got a little animation there and different fonts. Now, if I press enter, I'm going to go to text place. You see it says tries equals 1. And so every time I give it a wrong try, it will do that. Now, if I delete all this and put in the right code, 8675309, enter, you notice my LED changed, this changed to green, and I'm good. And then notice now too, my keyboard is locked out. So I have to reset it externally. I can't remember how I did the feature. I've got to look at it really quickly. So there are subroutines here in these hotspots. So the HS reset, if I call that from the propeller, assuming I had this connected to a propeller and I want to reset it, I could call the click event for this, and this will reset everything. You'll also notice too that here's my solution, and I can change that on once I start the program. I can change the solution so that it's not locked into the code. I can change that externally. So here's the HS enable keys. Yeah, so this is the thing. So if I'm running this again, if I call click HS enable keys, if I disable the keys while the timer is running, you notice how the time changed to yellow. It's still running, but my keyboard's locked out. So, you know, if I was using this in an actual escape room, then again, this would be, hey, you tried too many times. I was very tired a couple of weeks ago and was out for a long walk and stopped at an ATM, and I misentered my PIN code 3 times, and Bank of America said, swing and a miss, we're disabling your card for 24 hours, which was really annoying. But it's the way the world works. And so you could do that in here. If people, you know, want to just play the guessing game in an escape room, you can use logic to deal with that. Now, on the propeller side, if after 5 minutes of penalty box, you say, okay, we'll give you your key back. So we just do this click event again, and we'll re-enable the timer. So notice the display went back to red, and now I can put in the best passcode in the universe, and I can stop the clock. Okay, let's spend just unless there's any more questions on NEXTION stuff. I know we've covered a month worth of stuff in a couple of hours, but I want to show you a little bit of the propeller code. So if you're playing with it during the week, it'll make better sense. Is that okay?
Yeah, but I have one question here.
Yes, ma'am.
Rather than having reset keys and stuff like that on this, you're going to your code and running a program. How does that work if you want this to be on a mobile device? Wouldn't you have to somehow have a way from the mobile device to reset things?
What I say,
Or put another
device,
button
Carol,
on this that says C?
Yeah, I think you're misunderstanding. This is a physical device. When I say a mobile device, I mean something I can carry around. I don't mean my phone. This is not generating stuff that goes to another platform. It generates stuff that goes onto this piece of hardware that I can talk to serially with my propeller. So I'm not outputting this to a phone or something else. Forgive me, I use the term mobile device. What I meant is something that I can carry around. Forgive me. Yeah, I realized when you said that, I thought, oh, I use that term. Yeah, this is not generating screens for a phone. So this is different. This is what I said. This editor is designed specifically to create this code that runs on this physical display. It's a touch panel screen. And then what I would do is I would connect a propeller to that, and that would deal with, and I'm going to show you the code now for dealing with the propeller.
Well, okay, since you say a mobile device, would something like a Samsung Galaxy tablet work?
No. Again,
Okay, that's what I'm saying. There's no mobile devices that will run this kind of code.
This
I'm-
that I
particular
know of.
portable display.
I'm going to ask you to be a little less persnickety with my language because I said by mobile device, I meant something I could physically carry. So forgive me. I didn't mean to imply it goes on a phone. It goes onto this hardware and I can carry it.
What is that you're holding up?
This is the topic of the presentation. This is a next-gen touch panel HMI.
Oh, okay, I got you now.
Okay. All right.
Yeah, Ken sells those. Don't you,
Hey,
Ken?
John, is that pressure sensitive
Yep.
on input or just click and go?
I'm not sure I understand your question.
Capacitive versus resistive, I think
Yeah.
he means.
Oh, they have both versions. This is a resistive touchscreen.
Okay.
So it's pretty straightforward.
When you get up to intelligent, you have a choice of choosing capacitive or resistive.
Yes.
All
Yeah.
the
And they have,
lower ones are resistive.
yeah. Yeah. There are different families that have different features. So all of this tool that we've been talking about is to generate compiled code that goes into this touchscreen display that then we can serially talk to a host processor. I choose the propeller.
Mhm.
But there's lots of, now the code that I'm going to show you, I'm going to talk in generic terms, because if you look, as I did for the last couple of months, I spent a lot of time watching what other people are doing with the device. A lot of people are using the Arduino. Now, the people that do use it, that IT makes a library available for it, but even some of the people that are doing the better displays are saying, yeah, I'm just using straight serial. I'm not using their library. It's a little convoluted. In my case, again, most things are fairly discrete. We're pressing a button, we're moving a slider, we're doing something like that. So just as, here, I wish I could remember what this field is called, where I could say label.txt equals quote John close quote, so that here's an object equals here's a value. I'm doing the same thing on the output side. Even on this timer, the last message was locked equals 0, which means the person has succeeded. So, like, for example, my friend Dexter, who makes escape rooms, the way I would imagine he would deploy this if he did, he has the ability to connect into another system. So the propeller would get this, it would unlock the door using maglock or something. He would probably run some external lights and he would send a message into his audio system that plays music. So it's a multi-piece kind of thing. I did this, again, I was inspired by what he does because I've helped him with some propeller code with some mechanical keyboards that were more costly than this display. And this you can change and do, interesting things. This is not just a keyboard input. It has a live display. It shows you time. It shows you what you entered. That's what I like about it, is the flexibility. Okay.
Okay, so you could make this program, could you make your keyboard program be such that everything could be done by the keyboard? You wouldn't have to keep going to your code and running a program.
Well,
The reason for asking that is because from time to time, I don't always remember where I put a certain program or a
well,
certain feature.
if
I don't
you,
want to have to go searching for it on
I'm certain.
what's essentially a mobile product.
Right, but for example, like I was saying, Carol, on the what do I do with it? There's a family of the displays that have I/O on them. The basic display that we put into the list doesn't have any I/O. What they call the enhanced series does have I/O. It also has a real-time clock. So when you look at the various families of the NEXTION displays, they come with different feature sets. So you could, with this, if you could run this program and connect one of the local I/O points through an appropriate buffer to control the mag block directly. Now, you know, many of us are very into using, you know, the pixels like we're going to talk about next week and the week after. If you wanted to control them in conjunction with this, you would have to have a host processor, because this does not have the ability to generate data for neopixels or any of those kind of strings. So there's going to be that limit. So there are things you can do standalone, absolutely. But I'm focusing, you know, in projects like with, I've mentioned many times, my friend John, who owns a company called Johnny Jib. So he makes camera platform control systems. So he's got a very big display that he's building. And as I was, you know, assisting him, some of the strategies for how I'm doing things make sense to me, because I'm kind of echoing what they're doing. Again, when I want to change the text, you know, when I want to change this text field, I say, because this is text actually, to say, you know, name.text equals something. So my output, that's my input. So my output from this is some feature that I care about in the propeller equals some value that I've just changed on the display. They're kind of a mirror, and it makes it really easy. So going back to this, I'm going to go back to our first kind of boring looking display, that the one that the demo that shows all the things. So this one is, there's no serial code in the -0. The -1 has the serial code in it. So remember, here's the objects that we have. And here. And when I run this, if I move the slider, I get a message out once I drop the slider. And so in this case, it says level equals 24, and it follows up with a carriage return. It also changes here, here, and here, you know, so there's a lot of updating that's going on inside that hotspot. But I can control any of these things remotely. Like this toggle button is called BT0. Oh, sorry, if I do click BT0, BT0.0. Oh, that's interesting. So I did the click event on it. That was supposed to go off like that. So I should probably do demos that I haven't practiced, but there are things you can do. You can control the display through externally, which may be useful. In my case, I just care about these messages. So going over to the propeller side, as I've done in the past, and this is especially for the new people, I start very simple. So this NEXTION viewer project, this just looks at the messages. Now I can't run this through the simulator because I can't. If it looks like I'm straining, it's because I'm trying to get around all of trying to get around the Zoom window stuff. All right, so here's my viewer. I have that program that I just showed you in the simulator running on my NEXTION. So I just move the slider, and so you notice now I have this string. So I'm outputting from the NEXTION in plain text so I can read it in a human format. So if I click, here's my press button. Now I'm holding the button on the screen. When I release it, I get that release event, the 0. Here I can go, I'm going to go through the check boxes. And they identify, you can see check 1, I clicked them out of order. Now, since the toggle is active, I can change the screen. So you'll notice it is telling me which stooge is being shown. So this is how I'm doing output. In John's project, he wanted to set a bunch of parameters for a lens, for example. So we do this. We say, here's a feature of the lens and here's the value that you just entered. And so his propeller code knows how to deal with that. So that the next stage, of course, is parsing these things. So in version 2 of this project, now you won't be able to see this running, of course, because it's running on my system. This is a terminal version. So it looks the same, but I can, for example, I know that that text object is called T0. So when I started typing, the propeller saw that I was, and it put me into an entry state. So those 3 arrows mean, okay, here's the text you're going to send. So if I say T0.txt equals Johnny Mac. I don't know if you'll see this through the camera, but on the display right under my fingers, it says Johnny Mac now. So this, notice this text is the same as that I typed in through the simulator. This is why in that process that I talked about in the very beginning, test everything in the simulator. And then now I'm kind of testing it external of the simulator here. Version 3, again, these all build on each other. This version, oh shoot, come on, John.
Since you're using the propeller, can you write this in any of the propeller compatible languages?
Of course.
Or do you have to use Spin?
No, well, I'm using Spin, but this is why I kept it very simple, because serial, every language is capable of dealing with serial. I think he's on the stream. Bob in the forums, he's doing stuff with Python. You know, there's we talked in the very beginning that, you know, BASIC is becoming very popular again with the propeller because compiler. So there is no reason, I believe, why you couldn't do this in any language. Again, the Arduino people are doing this. I'm claiming I didn't invent any of this, or I didn't create it. I looked at the good ideas that people were demonstrating on the Arduino and said, I can do that on the propeller, but cleaner. I think Spin is a cleaner language than the other ones, but that's an opinion. You know, if you prefer C or BASIC or Python, have at it. It's understanding the process. So you saw it's something equals something followed by a carriage return, because that's what that's what I'm using. That carriage return character, hex 0D, is what my parser is using to say that's the end of a message. So this one will do the parsing. So if I'll go through this one. I'm going to drag my slider again. And
I think, John, even a BS1 could do it, right?
Technically, but you can't, you know, it would be easy to control this. You know, you could send messages from the BS1. Getting messages back would be problematic. You really need to be able to buffer serial messages from the display. But if you wanted to use this as an output from the BASIC stamp, you could. Because you can set the terminal, the baud rate is settable from, I think, from 300 all the way up to about 1 meg. It goes quite fast. In fact, in this version, I'm using, for this display, I'm using 9600, which is the default, but you can make it much faster. In fact, remember when I was doing that, well, the heart rate thing, you know, we're sending a lot of messages. You can see here, I was using, you know, a much higher baud rate. And just so that we're clear, I want to show people when you're dealing with your baud rate in your NextGen project, you set that in this tab up here. It says program.s. I don't know why, but you set your baud rate like that. So set it to whatever baud rate you want, because the propeller, since we're bit banging the baud, you could actually, well, yeah, sorry, I'm going to take that back. You need to make sure it's a baud rate supported by the NextGen, which is going to be any of the standard baud rates. I've tested up to 230, 400. But on downloading, you can serially download or upload. You see where it says upload right here? You can upload directly if you have the NextGen display hooked up to, you know, from, you know, one of these guys, a little USB to serial adapter. I've uploaded at 960,000 baud, whatever that baud rate is. So it works quite well because they probably got a hardware UART on the board. Okay, back to the propeller code. This one, let me show you, this was my screen. So here you can see, here's where I dropped that, you know, command. So I set my level to 36. So now it's been parsed. I have a command string of level. Now internally, and I'll show you, I've converted to a command index of 1, and then here's my value. So this is what now I can use to do practical things. I've converted that level equals 36 into a command string, which then I ran through a simple little function to give it a, convert it from a string to a number, because that's easier to use and control. And then here's my value. So this is all parsed out. So looking through here, let me show you very quickly. Here's the code that looks for a message from the NEXTION. And it's very simple. If it's an ASCII value, it adds it into my buffer. If it sees a carriage return, then it's done, and it passes back the length of the input string. Notice how we're passing a pointer to the buffer and the maximum number of characters we want to accept. It's pretty straightforward. Should be able to do this in any language. Now, you'll remember when I made mistakes, and either accidentally or deliberately, the NEXTION said 1A, FF. It gave me a system message that is in their format, their binary format. So what this method has built into it is a counter for the value FF, because I'm sending everything as ASCII. So FF is not going to appear. A character FF should not appear when everything is okay. So what happens is, if I get that, I go ahead and I add it into my buffer. And then if the count of that character FF, if I get 3 FFs, then I say I'm done, and I return the length as a negative value. What that tells me is that I had a mistake somewhere and I can deal with it. And then if this, I call this, and if there's nothing waiting, it'll just jump back out. So since this has the ability to do a terminal thing, I can show you that error processing. So remember, if I say t0.txt equals John, now my display changed. I don't have a T1 object on here. So if I say t1.txt equals Ken. So the NEXTION responded back with a code that I know, because I looked it up, that 1A means that that object doesn't exist. So the parser is smart enough to handle normal messages and their internal error codes. So this, again, this is for my system, but that little bit of code handles receiving a message and getting an error message if you do something that's wrong. This section here, I won't go into a lot of detail, but what it does is it goes through that string. It looks for the equal sign, and it pulls the left side and it puts that into a command buffer, and it takes whatever's to the right of the equal sign and before the carriage routine, and it puts that in this value buffer. So these are both string buffers. So all it's doing is breaking apart that string, and it's, again, to the left of the equal sign goes into this buffer, to the right of the equal sign, if the equal sign is in the string, goes into that buffer. This is a very simple conversion to decimal. I added a couple of things in there in case I get a little, if I make a mistake, so that this handles it. So this will allow me to send positive and negative values. And then the last thing is, this is code that we used. Remember, well, some of you that might have been on the stream last year when we did the IR remote and we wanted to identify what the key code was. So I had a similar thing here. This list is all of the things that this project can do. So I can send the level, I can send the press from that button. Show pick is the toggle button. I have the 3 checkboxes, and then I have the radio buttons that will select which of the 3 stooges we're showing. So these are the commands. These are the strings that I'm going to see on the left side of the equal sign. What this code does is goes through and it takes my command buffer, it converts it to lowercase, just in case I was silly and didn't do that in the NEXTION, and then it searches for it here, and it will set it'll set a return value to whatever this index is between 1 and this number. So this is how I convert a string into a number that I can use for controlling things. And you know, and that's it. In the main loop, this code will, this is doing the normal display of things. Here's the normal display of the stuff you saw when it did the parsed values. When I did that error, you'll notice if the length is less than 0, that means I had an error code or a NEXTION system message. This displays that, and it does it in hex because it does a hex output. And the final thing is this checks to see if I press a button. So you remember when I started typing, this will take care of that. So it detects me typing and it says, okay, take everything up until you press enter. And you'll notice here, so it will send it out. Here's that string. This is my buffer. And then again, %3C means send this character 3 times. When we're sending messages to the NEXTION, they have to be, just like their messages coming back. Do I have that still on the screen? Remember this? A message ends with FF, 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 no matter going in or out. So that's one thing to be aware of, that these messages don't, the messages that I'm sending manually don't do that, but any other system message from the NEXTION does. And when you send a string up, you have to add that. So using formatted strings makes that really simple. If you don't have string formatting built in, you can do that in a loop or just manually send 3 characters. It doesn't matter. You just have to remember those 3 FFs is what the NEXTION uses to determine, okay, that's the end of a string. Now I'm going to process it. Okay, I'm really wiped out.
Jon, thank you.
Probably everybody else is too. We went really fast, but I wanted to give everybody enough information to be able to play this week. Next week, we'll talk more and get into specific propeller coding. Next week is going to be all about propeller coding and a little bit of extra NEXTION stuff and answering questions that come up in the week. So now you can ask anything you want of me, Ken, or anybody. I don't care. I'm available for questions.
Jon, all of these examples you've shown us are on the forums now.
Yes, they are.
Thank you.
Yeah. Yeah, I put them up earlier, but now that you've been through them, even though this was more time than I thought we were going to take, I apologize. But this is a lot of stuff. I've been playing with this display for about 2 months now and spent a lot of time so that I could, again, I have my laser tag project. I'm helping Jon, I'm helping Rick. I'm doing real stuff with it. I'm hoping that the demos that I created, I did them, I had all these. I didn't create anything specific for today except for the analog one, but I think that turned out well. And but I'm doing real things with this, and I want you to be able to do real things with this. So I hope there's enough information there. May have to go through the video a couple of times to digest it, but this will save you several dozen, anyway, hours of watching YouTube videos to get started with this thing.
Jon, there's a question in chat. Go ahead, Carol.
I was just going to say, if I order it tonight or tomorrow morning, can I get it before the next class?
You need to get these at the moment off Amazon.
Yeah, then you could have
Oh, okay.
the next day.
Yeah, yeah, okay.
Maybe somebody could find a link to it.
Oh, I can find it.
Yeah. So
I
just
get an Amazon delivery or deliveries almost every single
Yeah.
day.
me too.
Because I
So
buy
just-
my groceries and everything there.
Carol, make sure whatever one you get is so that you don't have to modify any of the screens. Make sure you get the 480 by 320 display. And they're normally those displays, because I think they're using similar screens. That has it's a 3.5 inch. So you'll see those specs, because I have the one I have hooked up is the basic display. This is the same size, but you know, this has a black PCB. This is the enhanced display. So they have different families, but these have the same mechanical characteristics. Oh, and let me show you that. I did promise that in the NEXTION. If I wanted to run this display on the enhanced, I have to tell my project that. So I'm going to go here into the device block. Why is that not opening? And so I can go in the device. So you can see this is set to basic, and it's set to 480 by 320, 3.5. If I go to the enhanced, I will now select that same size. Now on the display, there's a micro SD card. If you select 270, that will orient the SD card so it's up, and then the connector will be to the right. If you do horizontal 90, the SD card will be on the bottom, which may be inconvenient. Now, if you want a display like this, like some of the keypad things we did, then you're going to select vertical, and then you only care about which way your connector is coming out of the display, selecting between 0 and 180. But this is how, if you need between families, you do it on this device page right here.
Okay. So that's how you rotate your screen.
Yes. Yes. So, and I didn't cover that. I'm glad we did now. Yeah, because some of them were horizontal and some of them were vertical. And this is where you set it, is on the display orientation.
Okay.
And it also, John, when you set the different kinds of displays, it enables and disables features like the video and audio and stuff
Yes.
like that.
Yes, because the basic display has the least amount of features. The enhanced has more. The intelligent display, that's the one with the red PCB. You can see it has all kinds of, it has, the ability to do live video playback and audio playback. It has a speaker output port on it. It has IO. So this one, it's a little more expensive. It does quite a lot more. I haven't actually even turned this on yet. Interestingly, if you look how big this is relative to my other ones, but this one has less resolution. This is 480 by 320. This is 480 by 270. I'm not sure why.
And if you're a cruddy artist, your bad graphics look worse on a bigger display.
Yes, yes.
So any final questions for Johnny Max? We could give him a break here.
Just one, if you don't mind. Whenever I hooked mine up last night with the prop plug, I kept getting failures when I tried to upload to it. And I was about ready to pull my hair out what I had left, until I realized when I built the case for it, I left an SD card in the slot. When there's an SD card in there, it'll fail on uploads.
Yeah, I've gotten I didn't know that, but I've gotten very kind of procedural when I have an SD card adapter here. I have this plugged into my Johnny Mac. I turn off the Johnny Mac switch. I put the SD card in, turn it back on, wait till it says okay, Johnny Mac off, SD card out, Johnny Mac back on. This is why when I was saying a minute ago, if you don't need to use the PST or the P2 debug capabilities, like on that analog project or the temperature project, then do the testing through the simulator. It'll just save you all that headache of having to download into the display.
Yeah, I'm glad you showed us that. I didn't realize that. That's a good feature.
Yeah, I was telling my friend John, who I can now see on screen, and he just chimed in a minute ago about that. And I was like, oh man, I wish I'd have known this a while ago, because there's a lot of times when we were going through and testing features. John, can I show that that test that we did for the profiles?
Sure.
Yeah.
And if you get the audio version of the display, then
So, now is that playing through a display, or are you just playing that audio, John?
that's just on my phone.
Oh, okay. So that's it. But I saw there was somebody on the internet was showing they were doing an escape room thing with audio and all of that. So here is a portion of John's project. So in John's particular project, he wants to be able to have 3 saved profiles. Now these are going to be saved on the propeller. And so this is a case where we wanted to, we wanted the user to know what's going on. So we're using these crop objects again. So if I run this, I did say debug. Oh, I said compile, not debug. So that's fine. So right now there's nothing loaded. So if I say I want to load profile 1, so you notice what we did is that green means that's what's currently active. Blue means that's what we're selecting. So if we wanted to save profile 1 to profile 2, we could do that. And now it runs profile 2. But here's where, again, when I said in the beginning, think about your project. John and I talked a little bit about this to say, okay, what is the interaction that we want the user, and something that makes really good sense. So green means that's what we're doing. Blue means that's what we could be doing if we select something else. So here's a case where here's a screen and we have 3 versions of that. One with white, one with green, and one with blue buttons. So I like the crop tool. It's very useful for doing nice things. And that way, you know, John drew up these screens and then I showed him how to use the crop feature. This was a demo I did for him so he could incorporate it in, but it makes a really nice user interface. It's very easy. And if later he decides he wants to make this fancy with, you know, with raised buttons or lighted looking kind of things, all we have to do is change out the graphic. One of the things I didn't show you, in fact, I did it today on my escape room timer project. The gray background was really close to matching this gray, and I wanted to offset it so you could see it better. So if you have an image and you decide you want to change it, so let's say we wanted what's active or what's selected to be yellow. So we could redo this graphic and change the blue buttons to yellow, and then I gotta get out of the simulator, sorry. When I'm in edit mode, I can click on this resource and I can click replace, and then I can go grab my new image and put it in there and then run the program and I have the new image. So again, the tool is quite nice. There's a couple of niggly things that I found sometimes when you're resizing in one direction, it will adjust the other. So I tend to be watching over in the attributes box what's going on to make sure that I'm not getting things out of whack. So there's a couple of little things like that. In fact, watch if I move the, oh no, it didn't. What kind of tool do we have there? Oh, we do have a crop, but just be wary of that. One of the things that I also do, and we didn't do that on here, but in some of my projects, I think I do have it on this one. I have a layer that's called NEXTION positions, where you see these yellow outlines. That's where I want my entities in the NEXTION. So what I do is I output this and I bring it into the display and I set it at the top page. And then I use these yellow guidelines to put everything where I want it. And then I just swap that out for the off page. So it's just, you know, a way of thinking. You know, it's like taking a piece of paper and, you know, drawing, I don't know. You'll figure out your own, you know, ways. Again, I use Inkscape for so many things. This just made sense to me since some of the niggly adjustments in the NEXTION are a little tricky to do. And it's much easier to align and space things in Inkscape or other kind of graphics tools in the editor. So I kind of do it here and I use that for a guide for over here.
Okay, I'm going to stop recording now. And if there are any other P2 subjects anyone wants to discuss, we could do that now.